अस्सलाम वालेकुम एवरीवन, क्या हाल चाल हैं आप लोगों के। कुक्ड हैं। चलें, विल सी। अच्छा, बिफोर आई स्टार्ट, मैंने डिस्क्रिप्शन में एक लिंक डाली है। लिंक में आई हैव जस्ट कंपाइल्ड सम डिफिकल्ट पास्ट पेपर क्वेश्चंस व्हिच आई एम गोइंग टू सॉल्व along with the syllabus run through that we're going to do. ठीक है, along with the syllabus run through that we are going to do. So we'll do a run through and then we'll solve some questions. We'll do a run through of a topic. We'll solve some questions. S2 नहीं बेटा, S2 मैं नहीं पढ़ाता. I don't teach S2. So energy method delta Ke equals to summation. Okay, so everyone has a, not everyone, but there are multiple ways of using the energy method. ठीक है, mine is slightly different. Maybe आपने किसी और तरीके से किया हो. So books में it's slightly different. So it's best that you learn one and then you stick to that. Okay, you learn one and you stick to that. Simple as that. बजाय इसके कि आप multiple सीखें. Just learn one and stick to it. Kinematics graphs. अच्छा, I will be covering some graphs. ठीक है. I have some graphs also lined up. अच्छा, अब एक काम करते हैं. पहले आते हैं ज़रा on the first topic. Okay, which is basically coplanar forces. So yeah, no link so far? No, link is there. Link's got to be there. Any update of previous paper? Nope, no idea. Achha, before I start, I would really appreciate if you guys like the stream, if you haven't done that yet, and also subscribe to the channel if you haven't done that. Link is there, but just refresh this stream, you'll find it then. Okay? Yeah, I will teach you my energy method, although if you want to learn that from scratch, there is a link है नहीं, कोई मुझे ज़रा confirm करके बता देगा, कोई बोल रहा नहीं है, कोई बोल रहा है. Hello sir, is your entire audience from your native country or do you have from other country as well? Let's find out. Can you guys tell me where you guys are watching from? I know majority of the students will be from Pakistan, but there is link hai. So there you go, simple as that. Okay, so let's begin. Let's start with a very basic chapter, which is coplanar forces. Okay, I know you guys will probably not like me going over something so basic, but let's do it anyway. Okay, so sir, please do kinematics stream. Beta, ab kinematics pe stream karne ka there is no time to stream for kinematics. This is the last stream before May June exams. Next stream inshallah will be for October November exams. Okay, all right, so let's start. So coplanar forces are basically forces that are acting from a point. Okay, now there are two things to keep in mind: finding the resultant maybe, or maybe that they're in equilibrium. If you have to find out the resultant, what you do is all the forces acting towards the right minus all the forces acting towards the left. Okay, if you're given if you're told that they're in equilibrium, that means all the forces acting towards the right is equal to all the forces acting towards the left. That's one way of putting it. The other way would be that the sum of all the forces is equal to 0. Now, a couple of things to keep in mind. If you're using the sum method, then remember you have to consider a direction. Take one side as positive, take the other side as negative. So for example, let's take a question here. Okay, although I'll do a sample question also. But if you have a 24 Newton force, then that means its x component will be positive, its y component will be negative. Okay, so anything that's acting towards the right is considered positive, anything that's acting towards the left is considered negative, anything that's acting upwards is considered positive, anything that's acting downwards is considered negative. Okay, now this session will probably go on for like 2.5 hours. So I don't want to keep you guys waiting for too long, but 2.5 hours. Keep that in mind. So please keep the chat relevant. I don't want to put you guys on mute. I don't want to disable the chat. Okay, here's a question. It's from a very recent paper. You guys can download this PDF from the link that I've shared. So with every chapter, I'm going to solve a certain question. Okay, because coplanar forces is an easy chapter. I'm not going to solve a lot of questions from it. So let's see. So this says 3 coplanar forces. Acha, also, before I move on about coplanar forces, sometimes you have to write down the direction of the resultant as well. So the direction of the resultant, there are many ways of writing it. You can write down the direction either with the help of some other force, either with the help of some axis, like maybe 20 degrees above the horizontal axis, 20 degrees below the horizontal axis, 50 degrees from the positive vertical axis, or 50 degrees anti-clockwise. But the best way that I prefer is bearing. Okay, the best way that I prefer is bearing. However, if you're writing it using bearing, then a couple of things to keep in mind is that the bearing is always measured from the starting point. So if this is the resultant force, this is how you will measure the bearing. Okay, this is what I prefer. Or if, for example, let's say this is the resultant force, okay, it's in this direction, then the bearing will be measured in this direction. Okay, so that's what I prefer. Bearing is acceptable. Maybe you won't find it a lot in the marking scheme, but it is totally acceptable. We saw it in recent examiner reports that bearing is also totally acceptable. Yes, you can write it with the horizontal axis also, but when you're writing horizontal axis, make sure that you write it whether it's the positive or negative. Okay, now let's solve this question. Let's solve a question from coplanar forces. Let's see what it says. Clockwise, dekho, just make sure that whatever it is that you're writing, it's clear to the examiner. It's not ambiguous. Okay, ambiguous समझते हैं आप लोग? Ambiguous का मतलब ऐसा ना हो कि उसमें the information is not enough to come to one conclusion. Maybe the conclusion is enough that you have multiple answers. Okay, so it should just be one solid conclusion and that's it. ठीक हो गया? Okay, so I'm going to solve this question. Let's see what this says. Just a second, ज़रा phone silent पे कर दूँ, एक दो messages के जवाब दे दूँ, फिर I'll solve. Yeah, so this is from the February-March 2025 paper. I don't know if you guys have solved it, but it was a fairly easy paper. So here what we're supposed to do is, we're given that the forces are in equilibrium, we're supposed to find out the values of x and theta. Acha, I have a very specific way of solving questions like these. So what I like to do is, I like to make two-way tables. Okay, so x, 40, 30. So these are forces. Okay, so horizontally I write down the forces, and vertically I write down the components, meaning x component and y component. Acha, main kaam karo, I'm just going to disable the chat like I did last time, and I will keep on enabling the chat after every single question. Okay, and otherwise you guys will just keep on spamming it with irrelevant stuff. So as far as the x Newton force is concerned, you can see that it will have a positive horizontal component and it will have a negative vertical component. So here's what I like to do. I like to write the signs first. As far as the 40 Newton force is concerned, we can see that it will have a negative horizontal component and it's going to be negative 40. There will definitely be no vertical component. As far as the 30 Newton force is concerned, it will have a horizontal component of 0. Okay, and since it's acting vertically upwards, that means its vertical component will be 30 newtons. Okay. Now what we have to do is, we have to break down the x Newton force into horizontal and vertical components. So let's start with the vertical component. The vertical component will be x sine theta. The horizontal component will be x cos theta. So that means x sine theta. The horizontal component is x cos theta. And the vertical component is minus x sine theta. Why? Because it's acting downwards. Now, because it's in equilibrium, that means the sum will be equal to 0. Okay, or you can say left equals to right. It's up to you how you want to do it. Okay, there are many ways of doing it. It's really up to you. So x cos theta minus 40 is equals to 0. That's one equation. Clearly, this equation is not enough because there are two unknowns and one equation. But the other equation would be minus x sine theta plus 30 is equals to 0. Okay, so here's the second equation. Acha, be a little smart. Think a few steps ahead. You see sine theta and cos theta. Okay, so whenever you see sine theta and cos theta, remember that at some point, this is inevitable. Sine theta upon cos theta is equals to tan theta. Okay, this has to happen. And this is an identity we all know, irrespective of whether you're a P3 student or not. This is something that we do in P1. Okay, so this identity is a prerequisite. So since I want cos theta in the denominator, I will use the first equation and make x the subject. So if I make x the subject using the first equation, so x would be equal to 40 upon cos theta. And then I will plug this into the second equation. So that would be minus 40 upon cos theta times sine theta plus 30 equals to 0. So let's shift this across the equals to sign. So that would be 30 is equals to 40 sine theta upon cos theta. Okay, so let's cross out the zeros. What are we looking at? We're looking at tan theta to be equal to 3 upon 4. And now make sure that your calculator is in degree mode. A good idea would be that before you pick up your calculator, make sure that you reset it. Okay, so tan inverse of 3 upon 4 will give us the value of theta, and that's equal to 36.9 degrees. ठीक हो गया? Now we're given that they're in equilibrium. We found out the value of theta. Now next what we're supposed to do is we're supposed to find out the value of x. Now what's x equal to? X is equals to 40 upon cos theta. Now when you're using theta, use your answer key so you don't end up doing something known as premature approximation. So x is equals to 40 divided by cos of answer, and we get the value of x, which is equal to 50 newtons. If let's say you had used some rounded off value, you would not be able to get exact 50. You'll probably end up getting something like 49 point something, which will eventually round off to 50, but this is the benefit of using the exact value. Okay? So some very basic concept. There's not a lot going on in this chapter. The worst that can happen is you may be asked to find out the resultant and find out the direction, which I think we did a question in yesterday's class. So anyway, here we are. I'm going to enable the chat. Let's hear your thoughts. What do you think? So I won't recommend doing unreleased papers. Last year papers got. Yeah, so as soon as we're done, I'll just put this video in unlisted. Okay. Camera quality is bugging? What do you mean? Sir, I'm weak on practice. Will stream fix it? I don't think so. So if tan theta equals to minus 3 upon 4 hota, to you would take tan inverse of minus 3 upon 4. Okay, probably get an acute angle. Obtuse angle, sorry. All right. Now, acha. Here, string and tension. So this is the second chapter. Achha, these are my notes. Okay, you guys can download these notes for free. They are available on the website mathletebysart.com. Okay. So yeah, by unlisted I meant I will put it in private. Okay. Hey, let me worry about that, you guys. I appreciate the thought. But let me worry about it. Is it lagging really? मुझे ऐसा कुछ मैसेज आ तो नहीं रहा. अच्छा अब बर्दाश्त कर लो यार, क्या करें, इंटरनेट का पता नहीं क्या मसला हुआ है. Just put up with it. Sorry guys. Okay, so can you mention how we get the direction of tension? Yeah, we'll talk about that. ठीक है. अच्छा, just a minute. Let me close a few things. Maybe that will help. Okay, so let's have a look at a few questions. Now, we know that tension always acts away from the particle. Remember that whenever you have an object on an inclined plane, weight always acts downwards. The normal component is always perpendicular to the plane or perpendicular to the point of contact. ठीक हो गया? Okay. Now, if the object is on a horizontal surface and there is no external force, that means the weight is basically equal to the normal reaction force. Okay? All right. Now, tension, as we know, always acts away from the particle. If the rope is the same, or if it's, let's say, if one object is pulling the other, then in that case, tension will be the same. ठीक हो गया? Okay, if you have an object hanging vertically, the weight is acting downwards, and if it's in equilibrium, the weight of the object will be equal to the tension. All right, now, OA and OB are two light inextensible strings. If alpha is equals to beta, then it will be an isosceles triangle. Now, if you have an isosceles triangle, in that case, the two tensions will be equal. If it's not an isosceles triangle, tension will be different. And read the question carefully. The question will tell you, from the question, you will be able to judge whether the tension is the same or not. Like, for example, if sometimes the question will say that find the tension in so-and-so part of the string, like the question will say find the tension in this part of the string and this part of the string. That means tension is different. If the question says find the tension, that means the tension is the same throughout. Okay? All right. Now, if an object is being pulled by a rope, the pulling force applied by a person, motor, etc., acts in one direction, and tension force in the rope acts in the opposite direction. on the object being pulled, of the object being pulled hoga basically. Okay, so examples. Two light inextensible strings are connected with particle A of mass m kg is held in a state of equilibrium. So notice that the weight is acting downwards. Now what force will be balancing this weight? The two vertical components of the tension. These are the two forces that will balance the weight. ठीक है? Okay, now. अच्छा कोई moderator नहीं है आज? चलें, I'll just take care of it myself. All right. अच्छा अब इसके कुछ मैंने interesting questions निकाले हैं which we're going to solve. ठीक है? Especially those weird questions where tension is basically acting in the opposite direction. And so that's not exactly weird. So let's go over some questions. Like for example, here's a question. You can see here that this is a 5 Newton force. Okay, and where is the tension acting? This is the direction in which the tension is acting, away from the particle. Okay, so you'll have to break down. Now, if you read the question, there are two strings, which means you will have to break each tension down into horizontal and vertical components, and then you will have to find out the value of each tension. We'll do some questions like that, don't worry. I have taken out some questions. अच्छा, और चलो एक question करते हैं पहले. So, oh, wait a minute. Here's a question which I've taken. Okay? It's a slightly unorthodox question, okay? A little unusual from the normal tension related questions. अच्छा बेटा इधर मैं questions की फरमाइश नहीं ले रहा. I've just taken out a few questions and these are the questions that I will solve, and inshallah with the help of these questions you will be able to I wouldn't say cover the entire syllabus from scratch, but have a good understanding. Okay, now let's have a look at this question. Pay close attention. So basically, here the deal is, the diagram shows a block D of mass 100 kg supported by two sloping struts AD and BD, each attached at an angle of 45 degrees to fixed points at A and B respectively on a horizontal floor. The block is also held in place by a vertical rope CD attached to a fixed point C on a horizontal ceiling. The tension in the rope CD is 500 newtons and the block rests in equilibrium. Now, normally what you would think is, you would think that tension is acting in the opposite direction, okay? Acha, instead of, making a lot of exceptions to this rule, here's my advice. Okay, first of all, tension is not acting in the opposite direction, okay? Let's see in which direction is the tension acting, okay? Acha, I think stream थोड़ी lag कर रही है, just a minute. Just a minute. मैं ज़रा थोड़ी देर के लिए chat enable कर रहा हूँ. Tell me if the stream is still lagging. Only camera is lagging? Okay, what about the rest? The part that I'm writing, that's all right? Okay, if only camera is lagging, then forget about it. I would advise you guys to deal with it. Okay? Okay. So the question says, find the magnitude of the force in each of the struts AD and BD. So what does that mean? That means it seems like tension will be different, but let's see if that's really the case or not. Let's see if tension is really different or is it the same. Okay? अभी देख लेते हैं. If we normally think that tension is acting away from the particle, let's see if that makes sense or not. Okay? Let's see if that makes sense or not. So if you think about it, the force that's acting downwards is basically 1,000 Newton. Okay? The force screen is also lagging. Acha thero, let me just shift to hotspot. Just a second. Let me just shift to hotspot. कल भी यही करना पड़ा था. पता नहीं इस टाइम ही इंटरनेट को कुछ प्रॉब्लम हो जाती है. Okay, when I shift to hotspot, it's going to get disconnected for a few seconds. So don't panic. It will be fine in a few seconds, like I said. Okay, so I think it should be fine now. Okay, अब सही है? ठीक है, great. All right, so if for a second we do think that the tension is acting in the opposite direction, ठीक है? If let's say the tension, we do assume that the tension is acting in the opposite direction. So does that make sense or not? So notice that we have 1000 Newton acting downwards, okay, and only 500 Newton acting upwards. So does that make sense for tension to act away from the object? No, it doesn't make sense for tension to act away from the object. That means tension must be acting in the opposite direction, okay? That means tension must be acting in this direction. Okay, so let's call this TA or T1 and let's call this T2. Okay, it's even lag here now? I don't think so. I think it's fine. Khair. So let's break this down. Now, as far as the tension is concerned, notice that it's an isosceles triangle. Okay, Achha, I'll explain it again. So here, if let's say we do assume that tension is acting in this direction, okay, let's for the sake of argument assume that tension is acting in this direction, okay. So that means there will be a vertical component of tension acting downwards, okay, there will be another vertical component of this tension acting downwards, so two vertical components of tension acting downwards, okay, and the weight also acting downwards. So does that make sense? Only 500 Newton force is acting upwards and all the other forces acting downwards. So does that mean, can it be an equilibrium? No, it cannot be an equilibrium. Okay, so what does that mean? That means tension, okay, to balance, tension is acting in this direction. Okay, and this is something that you don't have to make a lot of exceptions, okay? You don't have to make a lot of exceptions, just figure it out there and then use your common sense, simple as that, okay? So, now let's break down tension. So we know that tension will have a vertical component. Okay, what will be the vertical component of each tension? The vertical component of each tension will be T sine 45. Okay, the vertical component of each tension will be T sine 45 and the horizontal component will be T cos 45 acting in this direction and the horizontal component of this tension will be T cos 45 acting in this direction. Okay, so T1, T2. Now, since there are no other horizontal components, here's what happens. T1 cos 45 is equals to T2 cos 45, which makes us realize that the two tensions are basically equal. T1 is equals to T2, and from now on, I'm going to call it T. Okay? Now, what are the forces that are acting downwards? The forces that are acting downwards is the weight, so that's 1000 Newton, plus all the other forces are acting in the opposite direction. So 1000 Newton force is the only force that's acting downwards. All the other forces are acting upwards. So there are two components of tension acting upwards. So that's T sine 45 plus T sine 45. And don't forget the 500 Newton force, which is also acting upwards. So let's take 500 across. So 500 is equals to 2t sine 45. And now we can solve for the value of t. So t sine 45, first of all, is equals to 250. And now once we solve for the value of t is equals to 250 divided by sine 45. So 250 divided by sine 45, what's that equal to? That's equal to 353.55. Okay, which correct to three significant figures will be 354 newtons. Okay, and remember you have to give answer correct to three significant figures. Open up any examiner report, you will notice that answers are given correct to three significant figures. Okay, and candidates are advised to follow this instruction. Don't take this lightly. Acha, Saad beta, I did explain that in detail. Okay, so I would suggest you watch that part of the stream again. If we take tension downwards a negative value and state of magnitude without the negative sign, yeah, so that's also acceptable. That's also acceptable. Okay. Okay, now moving on. A horizontal force of magnitude F Newton is applied to the block in a direction parallel to AB. Find the value of F for which the magnitude of the force in the strut AD is 0. Achha, why did we take it two times? Because there are two strings. So each string will have a vertical component of T sine 45. Iska bhi vertical component hoga T sine 45 ka? इसका भी vertical component होगा t sin 45 का, ठीक है? So would it be a big deal if we take g as 10? What else are you planning to take g as? G is taken as 10. In physics, I think it's taken as 9.81 or something, but in math, it's taken as 10. Acha. Ab let's see what this part says. So this part of the question says, a horizontal force of magnitude F Newton is applied to the block directly in the direction parallel to AB. So that means it's a horizontal force. Okay, what's it called? It's called F. अच्छा, ये apply करने से क्या हुआ? Find the value of F for which the magnitude of force in the strut AD is 0. So that means if the tension here is 0, that means this is as good as slack. Okay, this is as good as slack. Achha, why would there be normal reaction force? Normal reaction force is when an object is in contact with a surface. Okay, so please use your common sense. कल पेपर है आप लोगों का. Normal reaction force, reaction जब होता है जब एक object एक surface से contact में होता है तभी reaction आता है. ठीक है, अब ये तो हवा में है तो हवा कहाँ से normal contact force देगी? थोड़ा दिमाग इस्तेमाल कर लो. Why is it slack? Because the question says that the magnitude of the force in the strut AD is 0. So that means there's no force over here. Even if you don't show it as slack, just remember that it's 0. Okay, so tension in this string is basically equal to 0. ठीक है, आप भले उसको slack ना show करें. Now, अब सारा load किस पे आ गया? अब सारा load आ गया इस tension पे. ठीक है. Now all the load is on this tension. Achha, how exactly are we going to work this out? Let's see. So first of all, weight acting downwards, 1000 Newton. Okay, component of tension acting upwards, which will be equal to T sine 45. Okay, so T sine 45 acting upwards plus 500 also acting upwards. Okay, so in case you're wondering, where is this? So here it is. Let me draw this here. ठीक है, ये वेट आ गया 1000 न्यूटन और ये जो टेंशन है इसका ब्रेक डाउन करते हैं. Here's T. So this is T sine 45 and this is T cos 45. ठीक हो गया. So T sine 45 acting, sorry, T sine 45 will be acting upwards. Yeah. T sine 45 acting upwards, 500 Newton acting upwards. And what about the force that's acting downwards? That is equal to 1000. So that's equal to 1000. So that means T sine 45 is equals to 500, which means T is equals to 500 divided by sine 45. So 500 divided by sine 45, what's that equal to? That's equal to 700 and that's equal to 700 something. ठीक है, तो अब हमारे पास क्या आ गया? हमारे पास 700 something ये आ गया. ठीक है, 700.106. अच्छा, now this is not what we are supposed to find. Okay, this is not what we are supposed to find. What we are supposed to find is basically the F force. Okay, so what's that going to be equal to? That is equal to T cos 45. So T cos 45, the force that's acting towards the left must be equal to F. We already have the value of T, so we're just going to plug that in. So just use your answer key, answer into cos 45, you will have the value of F, which is equal to what? Which is equal to 500 newtons. There you go. ठीक है, now questions. Sir, but T1 is equals to T2 equals to T, दोनों में 0 नहीं होगा. बेटा क्यों दोनों में 0 होगा? Read the question. The question says that when you apply this F Newton force parallel to AB, only the tension in this part of the string is 0. Okay, not in this part of the string. ठीक है, अगर ये भी 0 हो जाएगा तो फिर आप खुद ही सोचो, फिर तो ऑब्जेक्ट जो है वो नीचे को आ जाएगा. Okay, if tension is 0 here and tension is 0 here, that means this object will eventually fall because there is, other than this 500 Newton force, there is no upward force supporting it. Okay, so imagine for a second that we cut these strings. What will happen to the object? Cutting these strings basically means that its tension is 0. Okay, so that means there is a 500 Newton force acting upwards and there's a 1000 Newton force that's acting downwards. So it will definitely fall. It will no longer be in equilibrium. Okay, and the question says that it's in equilibrium. Okay, now whatever it is that's mentioned, okay, an important point, whatever it is that's mentioned with the question applies to both parts. Okay, so this information applies to part A and this information also applies to part B. Okay, we can't take resultant force because there is no resultant force. It is in equilibrium. Okay, guys, please read the question. Please read the question. Do yourself a favor. Please read the question. You know, sometimes it's written in the examiner report that candidates are advised to read the question at least twice to be able to better understand it. So there you go. Please adjust your internet. Now my internet is fine. It's just that it's been acting weird for the last couple of days. Anyway, अच्छा अब एक और interesting सवाल है, and that's this one. This is a pretty cool question. What do you guys think? Who here got this question right in the first attempt? Who here got this question right in the first attempt? It's my nightmare. This one is tricky. Acha. Chale. So I'll solve this. ठीक है. If you got it right in the first attempt, that's brilliant. I don't expect all of you to be able to get it right in the first attempt. ठीक है. So, acha, what I'm going to do is, for as long as I'm solving this, I want you guys to pay attention. So I'm going to disable the chat. ठीक है. अब देखो, first of all, there are two surprises in this question. Normally, you don't think that at some point you will have to use circle properties. Okay, so we kind of have to use a bit of circle properties over here. Okay, a very small portion of circle properties. That's one surprise. And the other surprise is that we are basically used to resolving horizontally, vertically, or at max parallel to the plane, perpendicular to the plane. Okay, here the thing is there's no plane. It's a circular rod, I think. A ring of mass 4 kg is threaded on a smooth circular rigid wire. So it's a circular wire. Okay, so we're used to breaking down forces horizontally and vertically. We're used to breaking down forces parallel to the plane, perpendicular to the plane, but never in this scenario. Okay. However, in this question, this is what I personally feel. If you just get one force right, okay, if you just get one force right, I think it's easy to get the entire question right. Okay. And that force is basically the normal reaction force. If somehow you are able to get the normal reaction force right, I think you will be able to get the entire question right. Okay. Acha. Also, nobody will have any doubts figuring out that tension is acting in this direction. Okay. And the one force that I'm talking about that you should get right is basically the normal reaction force. Why? Because normal reaction force, we know the reason why we call it normal is because it's always perpendicular to the point of contact. Okay, normal reaction force is always perpendicular to the point of contact. So I feel that if you get the normal reaction force right in this question, I think the likelihood of getting this question right will go up. The probability of getting this question right will go up. Okay? All right, now let's talk about the weight also. Okay, let's talk about the weight. So weight, we know no matter what the situation is, weight is always acting downwards. Okay, so here's the weight. All right, now we are now basically going to resolve the forces perpendicular to this line and parallel to this line. That's what we're going to do. Okay, so think of this as the plane. We're now going to resolve forces perpendicular to the plane and parallel to the plane. That's what we're going to do. Okay? So this weight will have a normal component, a perpendicular component, and this weight will also have a parallel component, parallel to the plane, this imaginary plane. You can call this an imaginary plane, basically. Achha, the problem here is that we don't have any angles to work with. Okay, so what do? Well, now we have to think outside the box, and this is where basically circle properties come in. So first of all, notice that this angle will be equal to 25 degrees. Why? Because it's an isosceles triangle. This is the radius and this is the radius. So they're both 25, number one. Number two, this angle will be equal to 180 minus 25, which is equal to 130. Achha, here's the thing. If I extend this line a little, okay, now remember this blue line is an extension of this red line, and this is a straight line. This is a straight line, and this is basically an extension of it. So technically, these two angles will be the same. Okay, I repeat. If you look at this line and if you look at this line, let's zoom in. So if you look at this line, which I've extended just for the sake of calculating the angle, and if you look at this line, you will notice that this angle and this angle will both be the same. Now the question is, how do we find out this angle? How do we find out this angle? Okay, now let's think. Once again, you wouldn't think that you have to use circle properties, so this is a bit of a angles question as well. इसको हम थोड़ा extend कर लेते हैं. Okay, when you extend this, what happens? You have alternating angles. Okay, you wouldn't think that in M1. So this is 50 degrees, which means this is also 50 degrees, which means this is 25. And this angle is equal to 50 degrees. Okay. That means if you now break down if you now find out the component of the weight, which by the way is 40 Newton, if you find out the component of the weight which is parallel to the plane, that would be 40 sine 50. Okay. And this would be 40 cos 50. ठीक है, अभी इसको ज़रा संभाल के रख देते हैं साइड पे. 40 cos 50 and 40 sin 50. अच्छा, अब हमने वेट का ब्रेक डाउन कर लिया. ठीक है. Normal reaction force is already perpendicular to the plane. No need to break that down. Another thing that we have to break down is basically the tension, which I will break down using the color green. Okay. Achha. Let's draw a perpendicular line over here. You can draw this perpendicular line anywhere you want, by the way. You can draw it over here if you like. You can draw it here. It doesn't matter, because ultimately the horizontal and vertical component will be the same. Okay, now the horizontal component of this tension will be equal to what? Will be equal to T cos 25. The vertical component of this tension will be equal to T sine 45. ठीक है? अच्छा, अब it's the home stretch now. Sorry, not 45, 25. It's the home stretch now. I'm sure आप लोग chat को लिए थे, सबने चलाना शुरू कर दिया होता अभी. ठीक है? So we're almost at the home stretch. So I'll enable the chat for a minute. Okay, please don't go crazy. Let me know if, because now it's all downhill. So let me know if you have any questions so far. Okay, and please keep it relevant. You know कि बात कुछ चल रही है और आप सवाल कुछ पूछ रहे हैं. Crazy. I know. Tell me about it. This is from October, November 2022. Paper 4, variant 3. Okay. So I didn't understand the second part. What trouble was how to resolve. Yeah, that's exactly the tricky part. In this question, what you have to do is you have to sort of ask yourself, okay, how do we break down the forces? So you have to pick an axis. You have to pick an x-axis and a y-axis. So what we do is at the point of contact, we make an imaginary plane. And from there, we resolve perpendicular to this plane and parallel to this plane. Okay, so हम basically ये horizontal x, ये हमारे axis हैं basically. Okay. अच्छा, and this is a one-of-a-kind question. Okay, the thing is, this is a one-of-a-kind question. There hasn't been a question like this. Okay. अच्छा, अब ये एक और cartoon बोल रहे हैं friction का क्या होगा? Again, better read the question. Okay, majority of the times I'm just telling you guys to read the question. It says smooth. Okay, it says smooth. All right, now let's put this together and let's form an equation. So let's start with the horizontal components. Okay, when I say horizontal, I basically mean these components. Okay, these components. So there is T cos 25. Okay, T cos 25. This is the only force that's acting towards the right. What are the forces that are acting towards the left? The weight component, okay, and the normal reaction force. So T cos 25 is equal to the weight component, which is 40 cos 50 plus R. Okay, 40 cos 50 plus R, and there you go. Is this equation enough? No, this equation is not enough. So let's call this equation number 1. Let's put this on the side. So how would we get the direction of normal contact? Okay, ये एक अच्छा सवाल है. अब देखो, this is the ring. Tension is pulling it in this direction. Correct? Tension is pulling it in this direction. That means there's got to be a component of tension which is parallel and perpendicular. Okay? Which force will counter this? Which force is preventing this ring to move inside this circular wire? Which force is countering it? It's the normal reaction force. If, let's say, the normal reaction force is also acting in this direction, then what's the force that's acting in this direction other than the weight? That's not possible. Okay? So tension is acting in this direction. Okay? This is being pulled in this direction. Which is the force that's acting in the opposite direction? It's the normal reaction force. Okay. All right. Now let's look at forces that are parallel to this axis. Now, what are the forces that are parallel to this axis? This component of tension, which is T sine 25. So T sine 25. Okay. And what's that equal to? That's equal to this component of the weight, which is equal to 40 sine 50. 40 sine 50. Achha, with the help of this, we can immediately find out the tension. Tension is equals to 40 sine 50 divided by sine 25. Okay, so let's work this out. 40 sine 50 divided by sine 25. So that's equal to 72.50. So correct to three significant figures. That's 72.5. Now let's find out the normal reaction force. The normal reaction force would be equal to T cos 25 minus 40 cos 50. So let's plug in the value of T. So answer times cos 25 minus 40 cos 50. So that's equal to 40. Normal reaction force is equals to 40 Newton. Okay, let's just double check. So 72.5 cos 25 minus 40 cos 50. Yep, that's equal to 40 Newton. Okay? Makes sense? Yes, normal reaction force is always opposite. Okay, normal reaction force is always, so if you're pulling an object, so देखो basically ring में different होता है. With ring it's different. So if let's say in this scenario, since it's this ring is being pulled in this direction, what's the force that's preventing it? It's the normal reaction force. Okay, normal reaction force is acting in this direction. Okay. All right. Now, so this is a one of a kind question, which is why I thought I would solve it. अच्छा, अब आ जाते हैं kinematics पे. Let's move to the next chapter. I would definitely rate this question a 10 on 10. Okay, if not a 10 on 10, then definitely an 8 on 10. Where did the 40 Newton go? Okay. Which 40 Newton are you talking about? कोई भी force कहीं नहीं गई है. ठीक है, we've taken all forces. It's just that there was nothing to equate this 40 Newton with, which is why we didn't equate it with anything. Okay. So I'll give you guys a quick summary of it. So basically what you have to do in this question, the tricky part is deciding how to break down the forces. Okay. The tricky part is deciding how to break down the forces. So what we do is at the point of contact, we make a line which is tangent. Okay. Tangent to the circle. And the fact that it's tangent means that there will be a 90-degree angle. Okay. Now what we do is, here's the normal reaction force. Correct? Here is the weight. Now this weight will have a component which is parallel to this axis and also a component which is perpendicular to this axis. Achha, the problem that we run into is what's the angle? Because if you want to break down weight, you need the angle as well. So this angle will be the same as this angle, and then if you make a pair of alternating angles, since this is 50, this will also be equal to 50. So this is 50 due to vertically opposite. So you break down weight. This component is 40 sine 50 and this component is 40 cos 50. Okay, so think of it. So I'm going to call this a plane. This is parallel to the plane. This is perpendicular to the plane. Okay, now the forces that's also acting in this direction is the normal reaction force. Why? Because this ring wants to move here. The normal reaction force is preventing it from moving here. Okay, now as far as the tension is concerned, we also have to break down tension into parallel and perpendicular components. So you make a 90-degree triangle. The one that's opposite the angle is T sine 25. The one that's adjacent is T cos 25. And then you equate right equals to left. Now, when I say right, I mean all the forces acting towards the right of this line equal to the left. And all the forces that are acting up are equal to all the forces that are acting down. Simple. Yes, it's a good idea to write down how you got the angle. Okay, so whatever it is that you're thinking, you should communicate it to the examiner to make life easy. So now I'm going to solve a few kinematics related questions. First, we'll do a kinematics overview, and then we will solve a few questions. अच्छा, kinematics is perhaps the topic which has the most weightage. और मैंने kinematics के कुछ काफ़ी interesting questions निकाले हैं, which we're going to solve. Okay. So first of all, displacement time graph. Now remember, if you're asked to make a displacement time graph, this is very similar to O levels. The gradient of displacement time graph gives you what? The gradient of displacement time graph gives you velocity. Okay. Now, if a graph has an upward sloping line, that means the speed is constant. Okay, the distance is increasing at a constant rate. If it's a horizontal line, that means speed is 0. The distance is not changing. However, time is increasing. Then if this graph is is now going down, what does that mean? Going down basically means that the object has turned. Okay, why? Because we're measuring distance from a fixed point. And if you're measuring distance from a fixed point, that means the object is now going in the opposite direction. That's why that distance is decreasing. When it touches the horizontal axis, that means it's back to the starting point. However, if it goes beyond the horizontal axis, that means now it's traveling in the opposite direction. Okay, it is now traveling in the opposite direction. That is why the displacement has become negative. Negative displacement means that the object has gone in the opposite direction to which was basically in the direction opposite to which was considered positive. Okay, so like for example here, if you're measuring your distance, if you're measuring displacement from home, and by the way, what's displacement? Displacement is a measure of distance from a fixed point. So if you're at school, your displacement will be 10 kilometers. But if you're at the mall, which is 8 kilometers in the opposite direction, that means your displacement will be negative 8 kilometers. So if this is the point from where you're measuring the displacement, so when you're at school, your displacement will be equal to 10 kilometers. Why? Because rightwards is the direction that is usually considered positive. But when you're at the mall, at this point, your displacement will be equal to minus 8 kilometers. Okay. Now let's talk about velocity time graphs. What do velocity time graphs look like? If you have a line that is constant, it's an upward sloping line, that means acceleration is constant. If you have a horizontal line, that means acceleration is 0, but speed is constant. Horizontal line in a velocity time graph does not by any means mean that the object is stationary. No, it just means that the speed or velocity is constant, which means acceleration is 0. And then a downward sloping line basically means that the object is now slowing down. And when it hits the x-axis, that means it's at rest. Also, a velocity time graph can go below the horizontal axis, which basically means that it has now traveled in the opposite direction. Okay, some notes, some key points which you guys must go over. Gradient of velocity time graph gives acceleration. Area under the velocity time graph gives displacement. Whenever the object turns, its velocity is momentarily equal to 0. So this we will deal with. In kinematics when we're doing equations of motion. If the object reaches its maximum height and now it's going to travel in the opposite direction, so for a second, for a fraction of a second, its velocity will be equal to 0. And also remember, at maximum velocity, acceleration is equal to 0 meter per second. Here's a graph of an elevator. Okay, so you guys were asking for elevator related question. Here it is. So if you look at AB, this is the elevator going up, velocity increasing at a constant rate. BC, so what happens is the elevator reaches its maximum velocity and then it continues at this velocity for a certain time. And at this point, acceleration is equal to 0. Now CD, the elevator is slowing down. Okay, and at D, it's equal to 0. The velocity is equal to 0. DE, it's stationary for this time. So people are probably getting in, some people are getting off. And now the velocity is negative. What does that mean? That means now the elevator, it went up, now it's coming back down. Negative velocity means that the object is now traveling in the opposite direction. So that is why it's coming back down. Once again, it's slowing down probably because it's approaching the floor that it's about to stop on. And then it's gradually slowing down, decreasing its velocity. Why? Because it needs to stop. And this is the point where it stops again. Okay? So then there are some questions, some past paper questions. I think I'll solve some past paper questions. There were some interesting past paper questions which I would like to solve. एक बड़ा अच्छा सवाल था past paper में. So this is an elevator question. यही solve कर लेते हैं. ठीक है. Okay, now This question says the diagram shows the velocity time graph for a lift moving between floors in a building. The graph consists of straight line segments. In the first stage, the lift travels downwards from the ground floor for 5 seconds, coming to rest at the basement after traveling 10 meters. So that means the lift, once again, let's read it. The graph consists of straight line segments. In the first stage, the lift travels downwards. Okay, so we can see that because the graph is below the horizontal axis from the ground floor. Downwards from the ground floor for 5 seconds, coming to rest at the basement after traveling 10 meters. So that's basically this. Okay, now the distance that we're given is 10 meters. What does that mean? That means the area under the graph is equals to distance traveled. So for the first part, this is what we're supposed to find out. Okay, it's a triangle. We know very well that area under the graph gives us distance. Isco for a second, let's not call it V. Let's call it X. So half into base into X will give us the distance traveled, which is equal to 10. So that means 5 ones are, 5 twos are, X is equals to what? X is equals to 4 meters per second. So that means the minimum velocity was 4 meters per second. Or you can say the greatest speed reached during the stage is equals to 4 meters per second. Because it's asking for speed, please don't give it with the minus sign. Okay, now the second stage consists of a 10 seconds wait at the basement. So once it reaches the basement, it's waiting. Okay. In the third stage, the lift travels upwards until it comes to rest at a floor 34.5 meters above the basement, arriving 24.5 seconds after the start of the very first stage. The lift accelerates at 2 meters per second square for the first 3 seconds of the third stage, reaching a speed of v meters per second. Find the value of v. Okay. So once again, let's read. Remember, if you have to read the question twice, read the question twice. The second stage consists of a 10 seconds wait at the basement. So this is the second stage that the question is talking about. Okay, here's the second stage. We've dealt with the first stage. There you go. The third stage is where the lift is now moving up. Okay, so this is the third stage. The lift travels upwards until it comes to rest at a floor 34.5 meters above the basement. Okay, so that means this entire stage, in fact, is the third stage. Okay, and what's this area equal to? This area is equal to 34.5. Why? Because this is the distance traveled. Okay, now let's read it further. Then the question says, the lift accelerates at 2 meters per second square for the first 3 seconds of the third stage. Okay, so this is basically what we want. We know that the acceleration of this part is equal to 3 meters per second square. Sorry, 2 meters per second square. Okay, now what's acceleration? How is acceleration calculated? It's basically the gradient of the velocity time graph. So we need points. One point is 15, 0. The other point is 18, v. Let's find out the acceleration. So the acceleration will be v minus 0 over 18 minus 15. That's the gradient. y2 minus y1 over x2 minus x1 is equals to what? Is equals to 2. So that means v is equals to 2 times 3, which is equal to 6 meters per second. There you go. So part 2 bhi ho gaya. Part 1 bhi ho gaya, part 2 bhi ho gaya. The time during this third stage for which the lift is moving at a constant speed. Okay. So we want this time. Constant speed means that the velocity time graph is horizontal. So this is the time that we want. Now, what's the missing piece of the puzzle here? The missing piece of the puzzle is basically the area. So we are given the area under this graph. That's what we have to use. So for a second, let's call this T. Okay, so these are the two parallel sides. One parallel side will be 24.5 minus 15. The other parallel side will be T minus 18. Okay, so we're doing part 3 now. So in part 3, what concept are we using? We're using area under the graph is equals to distance. So what's the area? The area is 34.5. That's the distance basically. And how will we calculate the area? It's a trapezium. So half into sum of parallel sides. What will this parallel side be equal to? This will be equal to 24.5 minus 15. Let's see what that is. 24.5 minus 15. That's equal to 9.5. Okay, and the other parallel side is T minus 18. So 9.5 plus T minus 18 into the height. What's the height equal to? 6. And that's equal to 34.5. Now it's a matter of cross multiplying. 34.5 times 2 divided by 6. So this is equal to 11.5, which is equal to 9.5 minus 18. That's minus 8.5. So t minus 8.5. So that means t is equals to 11.5 plus 8.5, which is equal to 20. And make sense of your answer also. The value of t should have been a value which is greater than 80 and obviously less than 24.5. If, let's say, our answer due to some miscalculation came out to be 16. So you should not be okay with that, because how can you have a value which is in between 18 and 24.5 be equal to 16? And if, let's say, for some reason your answer came out to be greater than 24.5. So don't just blatantly accept whatever answer you get. Make sure that it aligns with the question as well. Okay, now just one last question, then I'll open the chat and hear what you guys have to say. Part 4, the deceleration of the lift in the final part of the third stage. So that means we want, once again, the points. So this point has coordinates 20, 6, and this point has coordinates 24.5, 0. So now let's use the gradient formula. So that's going to be 6 minus 0, y2 minus y1, upon x2 minus x1, which is 20 minus 24.5. So that's equal to 6 over minus 4.5. So what's that equal to? 6 divided by minus 4.5. That's equal to minus 1 whole 1 upon 3, or minus 4 upon 3 meter per second square. Minus 4 upon 3 meter per second square. But because the question is asking for deceleration, we will write it as 4 upon 3 meter per second square. There you go. Now, मैं chat खोल रहा हूँ. Please don't go crazy. Let's hear it. Three-part. The time during which the lift is moving at a constant speed. अच्छा, by the way, 3-part का answer 20 नहीं है. हाँ. पकड़ लिया आप लोगों ने. 3-part का answer 20 नहीं है. It's going to be 2 seconds. So it's going to be 20 minus 18, which is equal to 2 seconds. ठीक है. गलती हो गई भाई. Sir, the question says 34.5 meters above the basement. Does that mean the distance from the ground? नहीं. Because ये distance था basement तक जाने का. ठीक है. This is the distance from the basement. It doesn't say above the ground floor. It's from the basement. Okay, so that means once it starts moving in the opposite direction, from that point onwards, you start counting the distance, and that is equal to 34.5. Yeah, I'll do SUVAT questions also. Don't worry about it. I'll do SUVAT questions. So 1 का answer 2 नहीं. हाँ, बिल्कुल, I fixed that. Sir, can't we use v equals to u plus 80 in part 2? In part 2, find the value of v. Yeah, you could do that. v equals to u plus 80. You could totally do that because acceleration is constant. Go ahead. Sir, when we do momentum, can you explain how to find time interval between two particles? Okay, we have such questions. Okay, we have such questions. Okay, now let's move on to the next concept. Okay, so then we have, so you guys are very welcome to download these notes. Okay. Sir, what does the triangle mean for the basement thing? Like it's going down? No, it's going down. Okay, it stops. देखो ये मत समझो कि जब वो lift ground पे आएगी तब graph जो है वो horizontal axis पे होगा. No, if the object is going down, doesn't matter whether it's the basement or if it's going down from the 10th floor to the 7th floor. If it's going down, the velocity time graph will be below the x-axis because it's moving in the opposite direction. If it's going up, doesn't matter from where it's going up, but if it's going up, the velocity will be positive and the graph will be above the horizontal axis. Simple as that. Okay, वो basement आपको सिर्फ confuse करने के लिए दिया हुआ है. All right. Now let's talk about constant acceleration. So till what time is the stream? The stream will go on for, I think, 10:30 or something. Okay. I will give you guys a break. We'll take a break at around 9 for namaz, and then we'll continue in around 10 minutes. Okay. Okay, so constant acceleration. Now, when acceleration is constant, there are some equations that we use, basically known as the Suvat equations. Okay, so these are the equations that we have. Mostly we have these three equations. Okay, although you can use, I'm not sure if this is given in the formula, I keep forgetting, but this is also an equation, although not used very often, but this is also an equation that you can use. Okay, but if the object is moving under gravity, here we have, okay, it is given, brilliant. If the object is moving under gravity, then remember we take acceleration due to gravity to be equal to 10, okay, or to be equal to minus 10. How do we know that an object is not under gravity conditions if someone's cycling, running, or if it's a car or a train? Okay, but if you throw an object, if you drop an object, or if an object is projected, that means you are now under gravity conditions. And remember, it's positive 10 meter per second if it's going down. Just like when you drop an object, it accelerates towards the ground. Whereas if you throw an object up, it decelerates, reaches the maximum height, and then it starts traveling in the opposite direction. That's how it works. Okay, now, these are some very basic questions. I don't think now is a good time to solve them. What I would, however, like to solve are some past paper questions. So I'm just immediately going to jump to some past paper questions. Here's a question. Although this is similar to the graph related question that we did, so let's get this out of the way also. A bus travels between two stops, A and B. The bus starts from rest at A and accelerates at a constant rate of A meter per second until it reaches a speed of 16 meters per second. So let's draw this part. Constant acceleration means upward sloping line. Okay, and it does this for how long we don't know, but we do know that once it's done accelerating, it reaches a speed of 16 meters per second. Okay. It then travels at this constant speed before decelerating at a constant rate of 0.75 a meter per second square, coming to rest at B. The total time of the journey is 240 seconds. Okay, so that means once the bus reaches this speed, it then travels at this constant speed for how long? We don't know. But we do know that it then decelerates. Okay, it then decelerates and it comes to rest, and the total time for the journey is 240 seconds. So here we have 240. Okay, also don't forget that the gradient of this line is equals to A, and the gradient of this line is equal to minus 0.75 A. Why? Because it's decelerating. Okay, so just keep that in the back of your mind. So this is what the velocity time graph looks like. That's it, job done. Find an expression in terms of A for the length of time that the bus is traveling with constant speed. So basically from here to here, this is what we want. We want the length of time for which the bus is traveling at a constant speed. Okay, so let's call this T1, 0. Let's call this T2. Okay, so that means the coordinates of this point will be T1, 16. Okay, so T1, 16. We can find out the gradient by doing y2 minus y1, 16 minus 0 over T1 minus 0, which is equal to A. That means T1 is basically equal to 16 upon A. Okay, so swap places of A and T1, you'll have the value of T1, which is equal to 16 upon A. Similarly, for this point, these coordinates will be T2, 16. And once again, when we find out the gradient, we'll do y2 minus y1, 16 minus 0 over T2 minus 240 is equals to minus 0.75A, which I would prefer to write as minus 3 upon 4A. Now remember, what you have to do is you have to make T2 the subject. Okay, so let's do that. Let's cross multiply. So when you cross multiply, this is what you're dealing with. Or in fact, instead of writing 16 minus 0, let's just write it as 16. Okay. Now, if you're thinking that we can use equations of motion here, go ahead, feel free to do that. So 16 times 4 is 64. 64 divided by minus 3 upon A. So basically, minus 64 upon 3A is equals to T2 minus 240, which means T2 is equals to 240 minus 64 upon 3A. Now, what is the question asking for? The question is asking for an expression in terms of A for the length of time that the bus is traveling with a constant speed. So that would be 240 minus 64 upon 3A minus 16 upon A. Okay, so I'll go over this one more time. We find out T in terms of A of this point. Okay, how do we do that? We're given the gradient is equals to A So y2 minus y1 over x2 minus x1 is equals to a. We make t1 the subject, we get 16 upon a. We do the exact same thing for this. Remember, the gradient for this part of the graph will be minus 0.75. So t2 comma 16, so we do y2 minus y1 over x2 minus x1 is equals to the gradient, which is minus 3 upon 4. You can take it as minus 0.75a also, that's perfectly all right. So 16 times 4 is 64 divided by negative 3a, so that's minus 64 upon 3a equals to t2 minus 40. Make t2 the subject, this is what you get. And then you take out the difference, and that's it. That's the answer. This, by the way, is from October-November 2024, paper 4, variant 1. Okay, then the question says, given that the distance from A to B is 3000 meters, find the value of A. Now, what is it that's equal to the distance? It's the area under the graph that's equal to the distance. Okay, area under the graph, remember, is equal to the distance traveled. So what shape are we dealing with? We're dealing with a trapezium. Now, I do not recommend that you break this trapezium down into multiple parts. Okay? It just makes it complicated. Okay? Instead, what I will recommend is कि आप इसको take it as the entire trapezium. Now, how will you calculate the area? It's half into sum of parallel sides into height. So half into sum of parallel side. Now, one parallel side is clearly 240 right here. The other parallel side, notice that the question has already made us work that out. So that's basically 240 minus 64 upon 3a minus 16 upon a. ठीक है, इसको simplify अभी करते हैं in a minute. Multiplied by the height, which is equal to 16, is equals to what? Is equals to 3000. So 2 ones are 2, 2 8s are 16. What is 3000 divided by 8? That's 375. So 240 plus 240 is equals to 480. So 480 minus 64 upon 3a minus 16 upon a is equal to 3000. ठीक है. अच्छा, अब let's just a minute. इधर हम LCM ले लेते हैं. या एक काम करते हैं. Let's make our life easy. And okay, let me just think for a second. How can we make this easy for ourselves? 480 minus 3000. Oh, wait a minute. 3000 divided by 8, that's 375. ये तो मैंने किया ही नहीं. 3000 divided by 8, that's 375. Yep, we're good now. Okay. So 480 minus 375, that's equal to 105, which is equal to 64 upon 3a plus 16 upon a. So I've shifted this across the equals to sign and these two on this side. Let's take the LCM, which is going to be 3a, 64 as it is, plus 16 times 3, what's that equal to? That's equal to 48, is equal to 105. Achha, now I'm going to skip a few steps. 64 plus 48 is 112 divided by 3. Okay, sadly you can't simplify this any further. 112 divided by 3a is equals to 105. So 112 divided by 105 divided by 3. Okay, so the value of a is equals to 16 upon 45 meter per second square. And there you go. Is there another part to it? No. That is the final answer. All right. Now let's hear from you guys. Now I'm pretty sure some of you will say कि इसको हम इस तरह से भी solve कर सकते थे. Check MS, this is the correct answer. Should we solve any past papers tonight? No, not recommended. I will not recommend that you do any past papers. This is it. Sir, please, questions asking for common time and distance. Yeah, we'll do those questions, okay? So just look at this PDF. All the questions in this PDF, we're going to solve those questions. So what happens if we don't show that much working? Well, you lose marks, simple as that. So shouldn't it be 240 minus T2 in number 1? No, why would it be 240 minus T2? No, why would it be 240 minus T2? So you think save my exams, mocks? I haven't seen those. But won't the a and 3a get up to the numerator? Why would the a and 3a get up to the numerator? No, just take the LCM. Okay, and then what you can do is you can swap places of 105 and 3a and then solve for a. Simple. So the area under the graph in velocity time graph is actually the distance. That's correct. That is correct. Mock 2 MS in the description. I did upload it yesterday in the description. Okay, next question. A particle is projected vertically. Say if you cross multiply 64 upon 3 and 16 upon a, won't. We're not cross multiplying. Okay, we're not cross multiplying. We're just taking the LCM of a and 3a, which will be equal to 3a. Okay, who said we're cross multiplying? Acha, what do you mean 240 minus t2? 240 minus t2 will just give you this interval. We don't want that. We want the interval for which the train is traveling at a constant speed. So that's going to be t2 minus t1. So you will have to first find out t2 in terms of a and then figure it out. अच्छा x2 minus x1 is 240 minus t2. तो बेटा एक ही बात है ना. ओहो क्या हो गया बेटा, A levels में आ गए हो. If you take this as x2 y2, then this point becomes x1 y1. Okay, you can take this as x1 y1. In that case, this becomes x2 y2. Okay, so it really doesn't matter. If you take this as x2, then this becomes y2. Okay, and in that case, this becomes x1, this becomes y1. Okay, so it doesn't matter. आज क्या करें? आज relax करें, just watch the stream and then go to bed. That's it. Okay, now we're solving some interesting questions, I think, which have a bit of momentum and a bit of kinematics. So here we're now dealing with, Acha, before we solve these questions, there is a lot of theory related to kinematics, which I would strongly encourage you guys to go over before you go to bed. Okay, this is very important. So I'm going to read this. Okay, and for as long as I'm reading this, I'll keep the chat open, but when I'm solving the question, I'll close the chat. Okay. So remember, if the object is thrown or projected vertically upwards, that means the initial velocity cannot be 0. Okay? If the object is thrown or projected vertically upwards, the initial velocity cannot be 0. No, I wouldn't recommend that you revise tomorrow morning. Just go over the notes at max, not more than that. And if the object is going up, acceleration due to gravity will be minus 10 meters per second square. If, however, you drop it, that means, and the acceleration due to gravity will be positive 10. At maximum height / displacement, final velocity will be equal to 0. Okay, also very important. An object will fall back to the point of projection with the final velocity equal to the velocity with which it was initially projected. So if you throw an object up in the air with a velocity of 20, that means when it reaches the point of projection, it will have the same velocity. Okay, now. लैग आ रहा है फिर से. Okay. चलें इसको कंप्लीट करते हैं, फिर we'll take a break. Time taken to reach maximum height is equal to the time taken to fall to the ground. So if let's say an object takes 10 seconds to reach the maximum height, it will take 10 seconds to fall back to the ground. What do you mean, what app? My notes are available on the website mathletebysart.com. Simple. When two objects are traveling in the opposite direction, the sum of their displacements is equal to the distance apart at t is equals to 0. So that means before they start traveling, the sum of their displacements is equal to the distance apart at t is equals to 0. Okay, so we'll understand this when we're solving a question. If velocity turns out to be negative, it means the object is now traveling in the direction opposite to the one considered positive. If another particle is released p seconds later, then its travel time compared to the other will always be t minus p. So we solved a question where we said that if a particle is released 1 second later, that means its travel time will be t minus 1 always. Okay, now. If particle is back to the starting point, then displacement is 0. So that means if a particle, अच्छा ये जो मैंने key point number 4 है ना, ये उससे related एक diagram है. Okay, if let's say an object is projected vertically upwards at a speed of 5 meters per second, when it reaches the point of projection, it will be traveling at the same velocity. Okay, so this is an explanation of point number 4. Okay, if you throw it at 5 meters per second, at a velocity of 5 meters per second, then when it reaches the same point, it will be traveling at the same velocity. Okay, and if an object takes 5 seconds to reach the maximum height, it will take 5 seconds to come back down as well. Okay, now this is key point number 6. So for example, let's say this is A, this is B, and they are both 10 meters apart. For collision to happen, the sum of their displacements must be equal to 10 meters. Okay, so the sum of their displacements will be equal to 10 meters. Okay, now, key point number 7. If velocity turns out to be negative, it means it is now traveling in the opposite direction. So if, let's say, you take the upwards direction as positive and now the velocity is negative, that means it's now traveling in the opposite directions. Yes, these notes are available. They are available on my website, mathletebystart.com. Okay, key point number 8. If another particle is released p seconds later, then its travel time compared to the other will be t minus p. Meaning that if another particle is projected 1 second later, that means its travel time will be t minus 1. If it's projected 2 seconds later, its travel time will be t minus 2. Simple as that. Okay, key point number 9, that if particle is back to the starting point, displacement is 0. So that means if you throw a particle up in the air and now it's back to the starting point, that means displacement is 0. However, if it goes below the starting point, that means the displacement will be negative. Okay? Alright. अच्छा, अब एक काम करते हैं. अब लेते हैं एक छोटा सा break. Okay? So I'm just going to quickly go pray. And I will suggest you guys also to do the same. Okay, when we come back, we have some really interesting questions to solve. We're going to solve question number 2. This is kinematics, where we have to use calculus, as in differentiation and integration, stuff like that. Okay. And then we will move on to Newton's laws of motion. Okay. So I'll probably be back by 10-15 minutes. Okay. 10 minutes minimum, 15 minutes maximum. All right, so at 9:15. Okay, I'll probably be back by 9:15. ठीक हो गया? So see you guys in about 15 minutes. Okay. क्या हाल है आप लोगों के? Are we back? Did I miss anything? No, I don't think I did. Chale. So let's resume. So we had basically just done some key points of kinematics. Okay. And now what we're doing is we are now going to अच्छा पहले ये देख लेते हैं ज़रा पहले ये देख लेते हैं S1 stream inshallah from tomorrow onwards. ठीक है. A particle P is projected vertically upwards with speed 24 meters per second from a point 5 meters above level ground. Find the time from projection until P reaches the ground. अब एक आपके पास there are two ways to do this. Okay. One way is that you break this down into two parts. You find out the time that it takes to reach its maximum height. Okay. You first find out the distance that it rises. That's 28.8 meters. So that means it's already 5 meters above the ground. It's going to go further 28.8 meters. Okay. That means the total distance is 28.8 plus 5, which is 32.8 or 33.8. Now let's find out the time that it takes to reach the maximum height. So that is 2.4 seconds. Okay. It will take 2.4 seconds to reach the maximum height. Now it needs to come back down. Now when it's coming back down, that means the distance that it will fall is 28.8 plus 5 meters, which is basically equal to 33.8. Now you calculate the time that it takes to fall back to the ground. So that's 2.6 seconds. So that means total is equals to 2.4 plus 2.6. Okay. I don't know what year this is. This is just explaining, I'm just explaining two methods. Now the other is that because the object is thrown up, that means whatever distance it travels up is positive. Whatever distance it travels below that, I mean in the opposite direction, will be considered negative. Now because we want to find out the time that it takes to fall back to the ground, that means its displacement from the starting point will be minus 5 meters. Okay, so that's what we're going to do. We're going to take the displacement as minus 5 because it's 5 meters below the starting point. Okay, this is the formula that we're going to use. Because it's thrown upwards, that means acceleration due to gravity will be minus 10. Achha, by the way, when we decided to break it down into two parts, so the part where it's coming back down, we take the acceleration due to gravity as positive 10. All right. So here we take it as minus 10, or you can just use this formula where this is ut minus half at square. And this way you will get the time directly. Okay. This way you will get the time directly. So is listening to music when studying bad? Definitely it's not something you will be able to do in the exam. So anything that you're not able to do in the exam is not something you should get used to. ठीक है, अच्छा, अब I've closed the chat for a while. I will open it. I want to solve some important questions, like for example, this question. Okay, so pay very close attention while I'm solving this. So this question says, a particle is projected vertically upwards from horizontal ground. The speed of particle 2 seconds after it's projected is 5 meters per second, and it is traveling downwards. So that means after 2 seconds, it's basically traveling downwards. Okay. Find the speed of the projection of the particle. Okay. So here's the thing. The particle is projected upwards from horizontal ground. So if this is the horizontal ground, it's projected upwards. So that means upwards direction is what's taken as positive. Okay. Now what is the initial velocity? We don't know. But we do know that upwards is taken as positive. Okay. We do know that upwards is taken as positive. If upwards is taken as positive, that means if it's traveling downwards, it will be negative. Achha. Also, we know that at t is equals to 2, its velocity, its speed is 5 meters per second, it's traveling downwards. So that means in terms of velocity, its velocity will be minus 5 meters per second. Why? Because after 2 seconds, it's traveling downwards, and the velocity at which it's traveling is basically minus 5 meters per second. Why? Because we've already taken upwards as positive. So downwards with a velocity of minus 5 meters per second. And when does this happen? This happens at t is equals to 2 seconds. Achha, because the particle is projected upwards, that means at the point of projection, the acceleration due to gravity will be minus 10 meter per second square. Okay. So what's the appropriate equation? V is equals to u plus at. So v is minus 5 is equals to u, which is exactly what we're supposed to find out, plus minus 10 into 2. So that means minus 5 equals to u minus 20. All right, let's delete this. And then u is equals to minus 5 plus 10, where minus 5 plus 20, which is equal to 15 meters per second. And there you go. That's the answer. ठीक हो गया? I'll explain this again. It's projected upwards, so we're taking the upwards direction as positive. After 2 seconds, it's traveling downwards with a speed of 5 meters per second. So that means velocity will be minus 5. All right. And acceleration due to gravity, because it was projected upwards, is minus 10. We use all this information, put it in the equation, and we get the initial velocity as 15. Find the distance traveled by the particle between the two times speed is equals to 10. Okay. Ab dekho, once again, making a rough sketch is very, very important. If you want any tips regarding M1, one very important tip is that you make a rough sketch. Okay, I cannot emphasize on how important that is. Let's have a look at the projectile. Okay, so it goes up, reaches the maximum height, okay, and then it comes back down to the ground. ठीक है, ये ऐसे curve में नहीं होगा, होता तो ये हमेशा straight line में है, but we draw it like a curve so that it's easy for us to sort of break the journey down. Okay, it always happens in a straight line. That's what kinematics is about. It's about an object moving in a straight line. Okay, so here's the deal. There will be two instances when the velocity is equal to 10. One is on the way up and one is on the way down. Okay, on the way up it will be positive 10, on the way down it will be negative 10. ठीक है, अब वो plus negative minus अभी हम figure out कर लेंगे. But it's important to understand that there are two times when the speed is 10. One is when it's on the way up, reaches its maximum height, final velocity is 0, then it's coming back down, and then it will reach a point where the speed is equals to 10 meters per second. Okay, so very important to understand this, that there will be two instances when the speed will be equal to 10 meters per second. Okay, now, here's the thing. If we just look at this part of the journey, okay, if we just take this part of the journey, we know very well that the final velocity will be equal to 0. Why? Because it reaches its maximum height. So this is the point where it has reached its maximum height. Okay, so the initial velocity, now remember, we are only taking this part of the journey. Okay, we are only considering this part of the journey. Okay, where the initial velocity is 10. Okay, the final velocity is equals to 0. And let's find out the time that it takes. Okay, in fact, not the time. Let's find out the distance that it travels, because acceleration will be minus 10. Let's find out the distance that it travels. Can we find out the distance that it travels? Let's see. I thought we were supposed to find out the time. We're not. We're supposed to find out the distance. So we can use this formula. 2as is equals to v square minus u square. So that means 2 into minus 10 into s is equals to 0 squared minus 10 squared. So minus 20, s is equals to minus 100. So s is equals to 5 meters. So that means this particle travels 5 meters up. Okay, and if it travels 5 meters up, it will travel 5 meters down. Okay, so I repeat. At the point where its initial velocity is 10, up until its final velocity is equal to 0, it travels a distance of 5 meters. Okay, so from this point onwards until it reaches its maximum height, it travels a distance of 5 meters. That means on the way down, when it reaches the velocity of 10 meters per second or speed 10 meters per second, it would have traveled another 5 meters. So what's the total distance that it has traveled between these two times? It has traveled a distance of 10 meters. 5 meters up, 5 meters down. So 5 plus 5 is equals to 10 meters. That's the answer. Okay, I repeat. So what we're doing is we're just looking at this part of the journey. From the point when the speed is 10 up until it reaches the maximum height where the final velocity is equal to 0. Okay, so this distance using this piece of information and this equation is equal to 5 meters. That means from this point onwards, the maximum height it reaches is 5 meters. So 5 meters up and 5 meters on the way down. So that means the total distance it has traveled is equals to 10 meters. Okay. Now I'll enable the chat. Let's see what you guys have to say. Sir, if time is t minus p, then if we put it in kinematics equation, बेटा p की जगह हमें कोई ना कोई वैल्यू दी हुई होगी, ठीक है? Like could be 1 second, could be 2 second, could be 3 second. In part A, it's traveling down at that moment, so y is acceleration. Okay. We always look at the acceleration at the point it's projected. So since it's projected vertically upwards, that means acceleration will be minus 10. Okay, at that point, it may be doing whatever it's doing. That's not a problem. But we will take the acceleration right at the start of the journey. At the start of the journey, it's going up. So that means acceleration will be negative 10. Okay. All right. So what if we take u as v and v as u? What kind of question is that? How long will the stream be? But if you have a problem, you can go right now. Sir, can we take final velocity as 10 and solve for 2 individual times, calculate the distance between? You could do that, but it's a 2-mark question. You could totally do that, but it's a 2-mark question. As in, you can find out the time at which it reaches a velocity of 10. Okay, you can find out the maximum height. You can find out the distance that it travels at t is equals to 10. And then you can subtract it and then double it. You could do that. It's going to take you forever, though. It's a 2-mark question. Okay, now let's move on. Okay, here's another kinematics question, except that here we have to use calculus. Okay, in this question, we have to use calculus. A particle moves in a straight line starting from O, the velocity of the particle at time t seconds. So we'll do those collision type questions as well. Don't worry about it. Okay. And this, by the way, is from May, June 2024, paper 4, variant 1. A particle moves in a straight line starting from point O. The velocity of the particle at time t seconds after leaving O is v meters per second. It is given that v is equals to so and so, where k is a positive constant. Now, there's probably good reason why the question is telling us k is a positive constant. Maybe we'll end up with 2 values. The maximum velocity of the particle is 4.5 meters per second. So we are supposed to use that information and find out and show that k is equals to 10. Okay, so the answer is right in front of us. We're just supposed to bring it equal to it. Okay, how can we do that? So maximum velocity means what happens when the acceleration velocity is maximum? Acceleration is equal to 0. Okay, that means we will equate acceleration to 0. We will find out the value of t, and at that instant, velocity will be equal to 4.5. ठीक हो गया? Okay, so let's differentiate. I hope everyone knows how to differentiate. So dv upon dt will be equal to half k t raised to the power half minus 1, which is minus half, minus 2 minus 0. So this is equal to a. So let's see if we can write this nicely. I don't think it's possible. Half k max we can do is take the square root of t, make it positive. So max we can do is write it like this. K upon 2 under root t minus 2. Let's equate this to 0. 0 is equals to k upon 2 under root t minus 2. So k upon 2 under root t is equals to 2. Let's cross multiply. We're supposed to find out the value of t. So we have k is equals to 4 under root t. Okay, let's solve for t. So we'll have to square both sides. Okay, so it's going to be k square is equals to 16t. T is equals to k square upon 16. Okay, so that means at this instant, the value of v is equals to what? The value of v is equals to 4.5. That's what we're supposed to do. Okay, we're supposed to show that at this instant, the value of v is equals to 4.5. Okay, now let's put this together. And we have plenty of space. Now, 4.5 is equal to k as it is. In place of t, remember we're going to write k. Also, okay, I just realized. We have found t, but this is t power half. So that means k square upon 16 raised to the power half minus 2 into k square upon 16 minus 8. Okay. So 4.5 is equals to k into k upon 4. 2 1s are, 2 8s are, minus k square upon 8 minus 8. Okay. So we have 4.5 is equals to k square upon 4 minus k square upon 8 minus 8. Let's shift the minus 8 across the equals to sign. So that's going to be 12.5 is equals to, let's just simplify this. 1 upon 4 minus 1 upon 8 will be 1 upon 4, but to be on the safe side, 1 upon 4 minus 1 upon 8. No, sorry, that's 1 upon 8. So 1 upon 8 k square. So 12.5 into 8, that's 100. So k square is equals to 100. Now remember, the question told us that k is a positive constant. इससे हमें पता चल जाना चाहिए that we might end up with two values. We do end up with two values, but we're only supposed to give the positive value, which is equal to 10. There you go. Okay? Now, verify that when v is equals to 0, t is equals to 1, and t is equals to 16. So that means we have the velocity equation. Let's write it down. V is equals to 10 t power half minus 2t minus 8. Minus 2t minus 8. So v is equals to 0. Let's plug in v as 0. So 10t power half minus 2t minus 8 equals to 0. This is a disguised quadratic equation. So let's take t power half to be equal to a. So that would be 10a minus 2a square minus 8 equals to 0. Let's write this nicely. So it's going to be 2a square minus 10a plus 8 equals to 0. So factors, I'm going to skip a few steps, but remember you're supposed to show your working. I'm skipping steps so that we can save some time. That's the only objective. Okay, but in the exam, you have to show your working. So we get a is equals to 4, or we get another value of a which is equal to 1. Okay, make sure to show middle term breaking over here. Acha, ab remember, a is not what we're after t. So t power half is equals to 4, which means t is equals to 16, and t power half is equals to 1, which means t is equals to 1. So we have found the two values of t when the velocity is equal to 0. Okay? Now, I'll unmute the chat because the last part I want us to solve together. Okay, in the last part, the question says, find the distance traveled by the particle in the first 16 seconds. Notice what is the question asking? The question is asking distance traveled by the particle in the first 16 seconds. So can I integrate velocity within the limit 0 to 16? What do you guys think? Can I integrate the velocity within the limit 0 to 16? Is that a good idea? Yeah, you can use quadratic formula, but whatever you use, make sure that you show the working. Okay, if you're using the quadratic formula, then just make sure that you plug in the values in the quadratic formula, then you can write down the answer. No, we cannot do that. Why? Because we cannot simply plug in the limits. Why? Because the velocity is equal to 0 at 2 points. The velocity is equals to 0 at t equals to 1 and at t is equals to 16. So if velocity is equals to 0 at 2 points, that means the particle must be turning and traveling in the opposite direction. So now what you will have to do is, you can't use the limit 0 and 16. Okay, so please be advised that you cannot integrate velocity within the limit 0 and 16. That is wrong. Okay, so instead what you will have to do is, you'll have to integrate velocity within the limit 0 and 1, then integrate velocity once again within the limits 1 and 16. And one of the answer will be negative, so you will have to make it positive because you're finding the distance traveled. Okay, so what's v is equals to? V is equals to 10 power half minus 2t minus 8. So first let's integrate this. So that's equal to 10t raised to the power half plus 1, which is 3 upon 2, divided by 3 upon 2, minus 2t square upon 2 minus 8t. Okay, so what are the limits? The limits are 1 and 0. All right, so let's do 10 over 3 upon 2. That's equal to 20 upon 3. So 20 upon 3, t raised to the power 3 upon 2, minus t square minus 8t within the limits 1 and 0. अच्छा, अब यहाँ पे मैं ज़रा थोड़ा सा time बचा रहा हूँ. I'm just writing down the final answer so that we can do some more questions. So 10x, and I hope you guys know that in your calculator you can integrate within the limits. ठीक है, मैंने integration करके दिखा दी. अब आपका काम है सिर्फ limits plug in करना. So when you plug this in, okay, the calculator is actually taking a while to work this out. Okay, this is no method. Okay, this is no method. The idea over here is that if the the particle, if the velocity is equals to 0, that means, अच्छा इसका आंसर आ गया, it's minus 2 whole 1 upon 3, and remember we'll take the absolute value, which means it's equal to 2 whole 1 upon 3. Okay, the logic here is this. Here's the logic. Please download these notes, it's very important. Yeah. For as long as the object does not turn, displacement equals to distance. If the object turns, then find critical values of t when the object turns before finding the total distance traveled. Okay? So what we're doing is we are basically, देखो, अगर मैं इसका एक rough sketch बनाऊँ ना, so this is what it looks like. ठीक है? This is probably what it looks like. It's a very rough sketch, but this is 1 and this is 16. Now I can't just integrate within the limits 0 to 16. Why? Because part of this curve is below the x-axis. Achha, how do I know it's below the x-axis? Because velocity was equal to 0 when? Velocity was equal to 0. Achha, nahi, wait a minute. Velocity was equal to 0 at t equals to 1 and t is equals to 16. So khair, this is not an accurate representation. But the graph, because the velocity is equals to 0 at 1 and 16, so the graph probably looks something like this. T equals to 1 and 16. So it probably looks something like this. Okay? So I can't just integrate within the limits 0 and 16. First I need to find out this area, then I need to find out this area. Okay? So you have to break it down. All right. Now, let's now integrate the same graph within the limits 16 and 1. Okay, so same graph within the limits 16 and 1. All right, so let's do that. 16 and 1. So what do we get? Let's see, what do we get? 45. Okay, so 45 plus 2 whole 1 upon 3, what's that equal to? That's equal to 47 whole 1 upon 3. So 45 plus 2 whole 1 upon 3, that's equal to 142 upon 3. So total is equals to 142 upon 3. There you go. All right. Now I'll give you guys a quick summary of it. देखो याद रखो कि if we are finding the distance using integration, then you cannot just plug in the limits and expect to get your answer. Okay? So what we have to do is, you have to first find out what are the instances that the object, no, if they asked you for displacement, then simply plug in 16, you'll have the displacement at t is equals to 16. Okay? But since we're traveling since we're calculating the area under the graph, okay, which is equal to the distance traveled, ठीक है, हम P1 में भी तो यही करते हैं ना कि अगर हमारा area इस तरह का है तो हम direct 0 और 16 limits नहीं लेते. We break it down. Okay, we break it down. First, we find out the area that's below the x-axis. We make it positive. Then we find out the area above the x-axis. We make it positive. Now, the question is, how do we know which part is below and which part is above? Let's answer that question. When you integrate within the limit 0 and 1, you get a negative answer, which implies that this part of the curve is below the x-axis. Now, here's the thing. Should you know that before you find out the total distance? No, not necessary. But you should know the instances when the velocity is equal to 0, and you should integrate up until those values separately. Meaning, we know the velocity is equal to 0 at t equals to 1 and t equals to 16, which means at t equals to 1 it's turning, and at t equals to 16 it's turning. So what we do is, we first integrate within the limit 0 to 1. We find out the distance traveled. Okay, we get a negative answer, which means this part must be below the x-axis. We make it positive, simple as that. Okay, then we integrate within the limits 1 to 16, so that we get the distance traveled from 1 to 16. And then what you do is, you get an answer. Since you want the total distance traveled, meaning you want the total area, you add this to this, and that's the answer. ठीक है? अच्छा, क्या बता दें भाई, क्या पूछ रही हैं आपकी अम्मी? I don't know where your question is, so just send it again. O level के लिए stream नहीं बेटा, O level के लिए stream रख ली मैंने, अब नहीं रखूँगा. We multiply the integral by 2 for distance if displacement is 0. Yeah, because the particle is back to the starting point. That's correct. In first part, we can also find time using velocity, then substitute in acceleration to find k. Yeah, you can do that. You can do that. Okay, try it out. Try it out. I'm not sure what kind of an equation you will end up with, but you're very welcome to try it out. Anyway, so that's that. अच्छा, अब आते हैं ज़रा न्यूटन्स लॉज ऑफ मोशन पे. ठीक है, so the only equation that you need to know as far as Newton laws of motion is concerned is basically forward minus backward equals to mass times acceleration. So let's go over this quickly. Oh, ये तो काफ़ी लंबी PDF है. Okay, so remember, smooth surface, no friction. That means an object will be rolling forever. Rough surface, friction exists and it will eventually stop. Okay, basic stuff, baby stuff, skip. Okay, net force. What's net force? Forward force minus backward force equals to mass times acceleration. What are all the forward forces? Forward forces could be the pulling force, could be the tension, could be the engine, could be its own weight component. Basically, every force that is helping the object move in a certain direction. ठीक है, that is pulling force. अच्छा बेटा, जब आप 0 to 16 इंटीग्रेट करोगे तो बीच में वो टर्न भी तो कर रहा है ना. अगर हमारा कर्व, कुछ part of the curve is below, कुछ part of the curve is above, so we don't just take the limits, do we? Okay, P1 अभी आप देकर आ रहे हो. P1 में हम ये तो नहीं करते थे ना, हम पहले नीचे वाले का हिस्सा, नीचे वाले पार्ट का एरिया निकालते थे, फिर ऊपर वाले का निकालते थे. ठीक है, so that's why we're doing what we're doing. Okay, once again I would strongly encourage you guys to download the notes and go over it. ठीक है, उसमें मैंने ये सारी चीज़ें मेंशन की हुई हैं. At this point I can't explain it to you from scratch because we don't have that much time. Okay, so that was that. So what are the types of forces? You have weight, which always acts downwards, irrespective of whether it's on a horizontal surface or irrespective whether it's on a inclined plane. It always acts downwards. Normal reaction force is always a force which acts perpendicular to the surface. So here's the normal reaction force. Here's the normal reaction force perpendicular to the point of contact. Okay? All right. Now, अच्छा बेटा, अब किसी ने भी मुझसे पूछा ना कि लाइव कब तक जाएगा, मैं I'm just gonna hide that person. Okay, starting from Hamad. ठीक है, so sorry Hamad, I had to set an example. There we go. Okay, ठीक है, because अगर आपको ज़्यादा प्रॉब्लम है तो जाके पढ़ लें भाई, nobody is forcing you. All right, now what is friction? Friction is a force which opposes the motion between two surfaces. Yeah. Tension, a form of a pulling force that's transmitted through a rope, cable, rod. अच्छा, baby stuff. Skip. Yep. You guys are very welcome to go over it. ठीक है. अच्छा, अब हम आ जाते हैं किस पे? This is also baby stuff. एक काम करते हैं, सीधा एक past paper question पे आते हैं. ठीक है. Let's just come to a past paper question. अच्छा, what's that? If we need to find displacement, then we can. अगर आपको displacement चाहिए ना, तो displacement हमेशा एक instant पे चाहिए होती है. So just integrate, plug in the instant at which you want the displacement, and that's going to be your answer. Okay. Sometimes they mention the forward force is horizontal. That probably means that the object is moving horizontally. It turns at t equals to 1, so can't do from 0 to 6. बेटा अभी तक एक चीज़ पे बहस चल रही है. I don't know आप लोगों ने पूरे साल किया क्या है. जब एक ऑब्जेक्ट टर्न कर रहा होता है, so that means कि उसकी velocity negative हो रही है. If the velocity is negative, that means the object is going. If you make a graph, that means it's below the x-axis. So you have to find that area separately, and you have to find out the other area separately. Just like if, for example, if I want to find out the area under this curve, I will not simply plug in these limits. For example, this is 0, this is 2. I will not do that. I will first integrate it within the limits 0 to 1, find this area, then integrate it within the limits 1 to 2, find this area, and then add them up. Okay? So same goes for graphs, same goes for velocity as well. Okay, and how do we know that the object is turning? Because the velocity is equal to 0. Once again, please go over the notes. When velocity equals to 0, there are two possibilities. One is it's the end of the journey. That's it. You've parked the car, velocity is 0, you're home. Or the other is object has turned. Because remember, in kinematics, our assumption is that the object is traveling in a straight line. So if in a straight line, you have to go to this point and then come back. Okay, imagine a car which goes in a straight line and then reverses back on and comes back from the same path. So it has to be stationary for a moment and then it's gonna come back in the opposite direction. Okay, so एक गाड़ी है, वो जा रही है ऐसे, और फिर जिस ट्रैक पे गई है उसी ट्रैक पे से उसको आगे जाके वापस भी आना है. सो ऐसे तो नहीं हो सकता ना कि यूं जाए वापस आए. ये तो जब होगा अगर वो यू टर्न करके आए. ठीक है, लेकिन अगर एक ही ट्रैक है और एक ही ट्रैक पे वो आगे जा रही है और उसी ट्रैक पे उसने वापस पीछे आना है, सो दैट मीन्स द ओनली वे टू डू दैट इज़ for the velocity to be equal to 0 for maybe a fraction of a second, but it is going to be equal to 0. Okay, so once again, I repeat, please go over the notes. Achha, also, in the notes, there's also an example which will definitely help you understand this concept better. Okay, this example right here. Okay, now, so let's do a couple of these questions. Okay, I've chosen these questions where you're supposed to find out the least and possible values of t, because these are the questions in which you guys have a lot of trouble. So let's see what we are how we're going to solve them. This question, by the way, is from October-November 2024, paper 4, variant 1. Question number 6. चलिए अब ज़रा तसल्ली से इसको solve करते हैं. A particle of mass 1.2 kg is placed on a rough plane which is inclined at an angle alpha to the horizontal, where sine theta is equals to 7 upon 25. Now the second you see sine theta is equals to 7 upon 25, a good idea would be to find out cos theta. Obviously not tan theta, you don't need that. So cos theta ke liye you need to find out the adjacent side, which is equal to 24. Please don't ask me how I've done this. So that's equal to 24 upon 25. I see. All right, now, the particle is kept in equilibrium by a horizontal force of magnitude p newtons acting in a vertical plane of containing a line of greater slope. The coefficient of friction between the particle and the plane is 0.15. So that means it's kept in equilibrium. Now, if it's kept in equilibrium, we don't know that this particle is about to go up, and we don't know whether this particle is about to come back down, which is why you're asked to find out the least possible value of p. अच्छा, least possible value of p कैसे निकलेगी? Let's try it out. Okay, you're not supposed to find out two separate values. You're supposed to find out the least possible value. So if for a second, let's assume that this particle is coming down. Okay, this particle is about to come back down. So let's break down the p Newton force, which we will have to do irrespective of where this particle is about to move. We'll have to break it down irrespective. So let's make a nice 90-degree triangle. Okay. अच्छा, this angle will be equal to theta. Why? Because of alternating angles. ठीक हो गया. अच्छा, P Newton is a force that's acting in this direction, so that means this will act downwards, this will act towards the right. So acting downwards, acting towards the right. अच्छा, so that means the force that is perpendicular to the plane will be P sine theta. Acting downwards, the force that is perpendicular to the plane, I'll actually write it over here, that would be equal to P cos theta. Okay, now let's break down the weight. Acting downwards, okay, this is the component perpendicular to the plane, component parallel to the plane. So the weight will be 12 newtons. This will be equal to theta. So this would be equal to 12 sine theta. Okay, now no matter where this moves, this will act down the plane, and this will also act down the plane, and this will be equal to 12 cos theta. Okay, it's very important that you annotate on the diagram, and if you're annotating on the diagram, my advice to you is that khuda ke waste, use a pencil, don't use a pen, because if you mess it up, that's it, you're doomed. Now, if the object is coming down the plane, so that means the frictional force will be acting up the plane. Correct? If the object is coming down the plane, that means the frictional force will be acting up the plane. Achha, अब the question is, in which scenario will we get the least possible value of p? When it's coming down or when it's going up? Okay, if you can figure that out mentally, brilliant. I know some of you may be able to do that, okay? But those of you who are unable to do that, no need to feel inferior. Let's do a bit of trial and error, no problem. Okay, and so it'll probably take us like 30 seconds. So if it's coming down the plane, then what are all the forces that are acting in that direction? So forward minus backward equals to mass times acceleration. So the one force which is acting downwards is only 12 sine theta. Okay, any other force which is acting downwards? No, that's it. Now all the forces that are acting in the opposite direction, frictional force plus p cos theta is equal to mass times acceleration, which means is equal to 1.2 a. ठीक है, 1.2 is the mass, a is the acceleration. अच्छा, अब एक काम करते हैं. Let's make p the subject and let's see what's what. Okay, we'll deal with frictional force in a second. So this will be 12 sine theta minus the frictional force minus p cos theta is equal to 1.2a. If I make p the subject, what do we get? We get 12 sine theta minus the frictional force minus 1.2a, which by the way will be equal to 0. Okay, I'm just writing this again and again to show that it's equal to mass times acceleration, which means it will be equal to, and since it's in equilibrium, that means it will be equal to 0, is equals to p cos theta. So that means, long story short, p cos theta is equals to 12 sine theta minus the frictional force. ठीक हो गया? Okay, now, what if the particle is about to go up the plane? Okay, so if the particle is about to go up the plane, in that case, the frictional force will be acting in this direction. Okay, if the particle is about to go up the plane, okay, use double arrows to show the direction in which the particle is moving or about to move. So in that case, the frictional force is acting in this direction. So what's the force due to which it will move up the plane? It's p cos theta. So p cos theta, the force due to which it will move up the plane. What are all the forces that are acting in the opposite direction? Its own weight component and the frictional force. अब once again आप देख के बता सकते हैं कि इसमें आपके पास p की least value नहीं आएगी. In fact, you will get the greatest value. Okay, why? Because p cos theta is now equal to 12 sine theta plus the frictional force. So this will give you the greatest value. Why? Because here p cos theta is equals to 12 sine theta plus the frictional force. Here p cos theta is equals to 12 sine theta minus the frictional force. Okay, so when you minus, you will get a relatively smaller value compared to when you add. So that means the scenario to consider is when it's going down the plane. Okay, now let's deal with the frictional force. The frictional force is equals to mu times r. So what about r? So this force is acting upwards. This is a force that's acting downwards. This is a force that's acting downwards. So that means r would be equal to 12 cos theta plus p sine theta. Okay, so r is equals to 12 cos theta plus p sine theta. Okay, let's have a look once again. R is equals to 12 cos theta plus p sine theta. Okay, so r is equals to 12 times 24 upon 25 plus p times 7 upon 25. Okay, so anything that I can do about this? I don't think I can, but let's just simplify it, write it nicely. 12 times 24, that's 288. So r is equals to 288 plus 7p upon 25. Okay, let's leave this as it is for now. Okay, now let's resolve forces parallel to the plane. So because it's about to move down, so that means this is the equation that we are going to use. Okay, let's copy this, paste it here. So 12 sine theta, and what sine theta is equals to? Sine theta is equals to 7 upon 25. Minus the frictional force. What's the frictional force equal to? Frictional force is equals to mu times r. That means 0.15 into 288 plus 7p upon 25 is equal to p cos theta. So that means p into 24 upon 25. Okay? Okay, so 12 times 7 divided by 25. What are we looking at? We're looking at 84 upon 25. अच्छा, अब 0.15 को एक काम करते हैं. 0.15 को हम लिख लेते हैं as a fraction. So that's going to be 3 upon 20 into 288 plus 7p over 25. ठीक है, is equals to 24p upon 25. All right. So looks like we're on the right track. Now let's solve this. How much space do we have? Okay, we're about to run out of space. अच्छा, that's because of this trial and error. इसको अब मिटा देते हैं. Okay, room निकल गया. Now, 3 times 288. 3 times 288 is equals to 864. 864 plus 21p over 20 into 25, which is equal to 500. Okay, this is 84 upon 25 minus, and this is equal to 24p upon 25. Okay. So अब एक काम करते हैं. Let's take the LCM, which is going to be 500. Okay, so let's multiply this by 20. Let's multiply this by 20. So 84 times 20, that's equal to 1680 minus 864 plus 21p is equals to 24p upon 25. Let's simplify. 25 ones are 25, 25 twos are 50, 0 as it is. Let's cross multiply. 24 times 20, that's equal to 480. Okay, so यहाँ पे 480p आ गया. ठीक है. 1680 minus 864, that's equal to 816 minus 21p. So 480 plus 21, 480 plus 21, 816 divided by answer is equals to the value of p, which is equal to 1.63. So 816 is equal to 501p, and p is equals to 1.628, which is equal to 1.63. And there you go. That, fellas, is the answer. Now let's see what are your thoughts. Here we go. To find the distance, could we have used your table method that is short? Zaki, if you're aware of that, yeah, I'm sure you are aware of that method because you're Zaki from AdMaths. Yeah, you can use that. Why did you plus p sine theta? Because it is on the upper side as r. P sine theta. Because it's acting up the plane. Reason why I added p sine theta is because... अच्छा, आप कहाँ पे बात कर रहे हैं? Yeah, so p sine theta. R is the only force that's acting up the plane, perpendicular and up the plane. This is down the plane and this is also down the plane. There you go. Sir, we turned the negative area into positive. Yes, that's correct. Can we please do a limiting equilibrium question? This is technically limiting equilibrium. Okay, this is technically limiting equilibrium question. So can we do relative speed, relative time, relative displacement type of questions? The one, and I think I have taken that question here in some of the questions. अच्छा, ये कर लेते हैं. This is another one of those questions where you have to consider two separate scenarios. 100K when? I don't know. Hopefully by the end of this session. Let's see. So how many significant figures should we use for normal answers and angles? Same rules. 3 significant figures, angles for correct to one decimal place. Sir, an easy short method? बेटा easy short method होता तो मैं इतना ख्वारी नहीं कराता आप लोगों की. आप लोगों को easy short method दे देता, and that would be it. Okay. अच्छा, how much time do we allocate for each question? देखो M1 में time can be a problem. So I can't give you I can't give you कि आपने exactly कितना time allocate करना because there is no guarantee whether you'll be able to do that or not. What I can tell you, however, is that there must be your strong topics. Start with those. Okay. Usually kinematics is, there are some portions of kinematics which students are comfortable with. Okay, so start with that. Walaikum salam. Mera bhi salam keh dijiyega unko. Acha, then there are coplanar forces. Get those done get those done immediately. It's very easy. Then leave time for the difficult questions. Questions where there are multiple forces to consider, where you have to break them down. And please don't take that part lightly. Don't think that breaking down forces is basically for the weak. That's not how it is. Okay, everyone should do it and take time out to do it so that you get it right. Walaikum salam. Mera bhi salam dijiyega unko. Yeah, we will do that. I have some questions in this PDF where we are going to consider some particles colliding. Okay, so I'll try and solve all these questions, inshallah, in this PDF. Okay, that's going to take a while. So let's speed things up. Okay, now. Sir, syllabus का एक full go through करवा दें जल्दी वाला. अच्छा बेटा, इसको तो मैं hide कर रहा हूँ, ये किसी काम का इंसान नहीं है. Sir, do you recommend opening the paper, scanning through the whole thing? Yeah, of course. Of course. You don't want to spend a lot of time on a difficult question and then realize that you've missed out on the easy questions. And when you solve a lot of time on a difficult question and you go into a state of panic, then you mess up the easy questions as well. Simple as that. Walaikum assalam. Nay, I don't recommend that you solve the exam in order. Okay, it's not like you will get extra marks if you solve it in order, and it's not like you will lose marks if you don't solve it in order. Okay, solve it in whatever order that you like. Start with the questions that you are the most comfortable with. Okay, now, a particle of mass 0.8 kg lies on a rough plane which is inclined at an angle of 28 degrees to the horizontal. The particle is kept in equilibrium. अब यही वो अगर बोलते हैं in limiting equilibrium तो आप सब परेशान हो जाएंगे. Oh my god, limiting equilibrium का question आ गया. ठीक है? But the thing is, here also it's kind of like limiting equilibrium. That means it's about to move and you don't know in which direction it's going to move, which is why the question is asking you to find out the least and greatest possible values of t. Okay? But if the question said limiting equilibrium, then you guys would be like, oh my god, what do we do now? Okay, so please don't freak out. If the question uses a slightly more complex term, it means more or less the same thing. Okay, now how will we find out the greatest possible values of t? Now the greatest possible value of t, so in the last question we did some trial and error. In this question, let's try and do it directly. The greatest possible value of t would be when only t is acting in the direction the object is moving and all the other forces are acting in the opposite direction. That's how you will find out the greatest possible value. So the greatest possible value will be when this object is about to move up the plane. Because when this object is about to move up the plane, that means its own weight component will be acting downwards. Okay, its own weight component is acting downwards, and not just its own weight component acting downwards, but also the frictional force will be acting down the plane. The frictional force will be acting in this direction. Okay, that means the only force that's acting in the direction the object is moving will be t cos theta. Okay, and now all the responsibility lies on this force, which is equal to t cos 35, and this is equal to t sine 35, and the normal reaction force, obviously that's not going anywhere. Here it is. So this angle will be equal to 28 degrees and the weight will be equal to 8 Newton. This is 90 degrees. This would be equal to 8 sine 28 and this will be equal to 8 cos 28. ठीक हो गया? Okay, now this will give us the greatest value when the particle is about to move up the plane. So greatest will be when it's about to move up the plane. Okay, why is that? Here's how. Because forward minus backward is equal to mass times acceleration. Now what's the forward force? The forward force is t cos 35. Okay, what's the backward force? The backward force is its own weight component, which is 8 sine 28. Okay, plus the frictional force. And because it's in equilibrium, that means it's equal to 0. So now let's have a look at the frictional force. So the frictional force is equals to mu times r. Now mu is 0.2. Let's find out r. R would be equal to t sine 35. Yeah, chalo, let's make an equation for r first. So r plus t sine 35, okay, is equal to 8 cos 28. R plus t sine 35 is equals to 8 cos 28. Okay. Now, that means the frictional force is equals to 0.2. Yeah, in fact, let's first find out the value of R, or find out an expression for R. So R is equals to 8 cos 28 minus t sine 35. That means the frictional force is equals to 0.2 times 8 cos 28 minus t sine 35. Okay. Let's simplify. 0.2 times 8, that's equal to 1.6. So the frictional force is equals to 1.6 cos 28 minus 0.2 t sine 35. Okay, now let's plug this in. So t cos 35 minus 8 sine 28 minus the frictional force, which is equal to 1.6 cos 28 minus 0.2 t sine 35 is equals to 0. Okay, so far so good. Now, there's a lot of working that needs to be done. First of all, t cos 35 minus 8 sine 28 minus 1.6 cos 28. We'll figure this out in a minute. plus 0.2, because minus minus becomes plus, 0.2 t sine 35 is equals to 0. Now let's keep all the t's on one side and everything else across the equals to sign. So t cos 35 plus, let's copy paste to save some time, plus this is equal to 8 sine 28 plus 1.6 cos 28. Okay, let's make t the subject. I'm going to skip a few steps. So t is equals to 8 sine 28 as it is, divided by cos 35 plus 0.2 sine 35. Okay, now I'll enable the chat for a few seconds. अच्छा, इसकी लीस्ट वैल्यू के लिए मैं सिर्फ इक्वेशन बता रहा हूँ, बाकी आप लोग खुद कर लीजिएगा. 8 sine 28 plus 1.6 cos 28, close the bracket, divided by cos 35 plus 0.2 sine 35. So we get 5.53. So this, by the way, is from May June 2024, paper 4, variant 2. तो आंसर भी चेक कर लेते हैं while we're at it. So we get 5.53. वालेकुम सलाम. जी जी बिल्कुल, मैंने सलाम का जवाब दे दिया है. आप लोग भी मेरा सलाम देते हैं उनको if he is still live. So 5.53 is what we get. That's the greatest value. अच्छा, इसके लिए you're given one extra page also. Okay, so don't worry about it. You're given one extra page. अच्छा, अब if you're supposed to find out the least value would be when it's coming down the plane. So least value would be when it is coming down the plane. And if it's coming down the plane, that means the frictional force will be acting up the plane. So if it's coming down the plane, that means the frictional force will be acting up the plane. So double arrow to show the direction in which the object is moving, and frictional force will always be opposite to the double arrows. Okay? Now, so in this case, जो हमारी equation बनेगी वो मैं यहाँ पे लिख लेता हूँ, and then you guys can solve. T sine, no, wait a minute. So basically, if it's coming down, that means it's coming down because of its own weight component. So it would be 8 sine 28 minus t cos 35 plus the frictional force is equals to 0. Okay, this is the equation that you will use to find out the least value of t. ठीक है, आगे इसको खुद ही solve कर लीजिएगा. Okay, now कितनी लंबी स्ट्रीम, चलो इसको फ़ौरन हाइड करते हैं. एम्बिगुअस रूल की इतनी कोई एप्लीकेशन नहीं. अच्छा भाई, ये कौन सी है? इंक्लाइंड प्लेन में वर्क डन अगेंस्ट रेजिस्टिव फोर्स में कंपोनेंट ऑफ वेट नहीं इंक्लूड करना, बिकॉज वो ऑलरेडी पोटेंशियल एनर्जी में आ जाता है. इट वाज नाइस मीटिंग यू. व्हेन डिड वी मीट? When did we meet? सर एक अजीब सवाल था. हाँ हाँ बोलें. Alright, अच्छा, this question I'm going to skip. You guys can solve yourself. ठीक है. In the meantime, I will solve it, but पहले ज़रा देखते हैं कि अगर if we have some momentum related questions. ठीक है, पहले ज़रा क्योंकि momentum आप लोग काफ़ी request करें, so let's do some momentum related questions. I've already taken some out, so let's do this question. So is there a quicker way of finding the ball will move up or down for greatest value question? नहीं बेटा, quicker way is बराबर वाले से पूछ लो. ठीक है, I don't think it's any quicker than that. ठीक है, अगर quicker होता I would probably given it to you, but it's not quick. Don't be lazy, put in some effort. Okay. So this is a question which is from October-November 2024, paper 4, variant 1. Okay, how much is left? We're left with quite a lot. We're going to do some momentum questions, some work energy power questions, and that's it. That's not it actually, that's quite a lot. Can we do pulleys? We will do pulleys also. I meant like virtually meeting you. Okay, चलें, it was nice in that case meeting you also. अच्छा, अब मैं कर रहा हूँ chat को बंद ताकि ज़रा सुकून से क्वेश्चन सॉल्व करूँ. So this is a question that we're going to solve. And reason why I've chosen this question is because there is a lot going on in this question. Okay. And it's October-November 2024, paper 4, variant 1. A particle A is projected vertically upwards. So there you go. आप लोगों की vertically upwards की ख्वाहिश थी वो यहाँ पे पूरी हो गई. ठीक है? अच्छा. What's happening after that? After that, it says, just a second यार एक चीज़ upload कर दूँ. Just a minute. Okay, so a particle A is projected vertically upwards from a point O with speed 80 meters per second. 1 second later, a second particle with the same mass A is projected vertically upwards with a speed of 100 meters per second. So notice some key points. 1 second later. ठीक है, यहाँ पे वो वाला concept use होगा that if another particle is projected after a second, that means its travel time will be t minus 1. Okay, because it will travel for 1 second less than the previous particle. Okay, all right. Now after that, let's see what it says. At time t seconds, the first particle is projected, the two particles collide and coalesce to form a particle C. Okay, so there's a lot that's going on here. Achha, let's see what happens after that. Show that t is equals to 3.5. Okay, so once again, let's break it down. Let's break it down and then do it. Please, I don't advise that you do it directly. It's practically not possible. A good idea is always to make a rough sketch. Okay, it's always a good idea to make a rough sketch. Don't take this lightly. Achha. So we have particle A, which is projected vertically upwards. Okay, and then you have particle B, which is also projected vertically upwards, but 1 second later. Now, A is projected vertically upwards at a speed of 80 meters per second. B is projected vertically upwards at a speed of 100 meters per second. ठीक हो गया? Okay, now, let's talk about the displacement of A. And remember, these two particles will coalesce. That means that their displacement will be equal. Okay, these two particles will coalesce. That means that their displacement will be equal. So let's talk about A. A is projected at a speed of 80, so that means its displacement will be, so the formula that I'm using is S is equals to ut plus half at square. So 80t plus 1 upon 2, in place of A we will have minus 10 into t square. So SA is equals to 80t minus 5t square. Okay, now let's talk about B. So B is projected 1 second after. So that means its travel time will always be 1 second less than A. Okay, so t minus 1 plus 1 upon 2. So battery dead hone se pehle I need to wrap things up. Okay. Now because the two particles collide, so that means SA is equals to SP. Okay, the two particles collide, so that means SA is equals to SP. So SA is equals to 80t minus 5t square is equals to 100 into t minus 1 plus nahi chalo ab ye minus 5 ho jayega into t minus 1 the whole thing square. Now there's nothing we can do with the left hand side, so we'll just copy paste it. There you go. But as far as the right hand side is concerned, that's going to be 100t minus 100 minus 5 into t square minus 2t plus 1. Okay, so 80t minus 5t square is equals to 100t minus 100 minus 5t square plus 10t minus 5. So minus 5t square cancel. Achha. So we have 80t plus 10t, so that's equal to 110t. 80t is equals to 110t minus 100 minus 5. That's equal to minus 105. Okay, now let's make sure that I've done everything correctly. 100t minus 100 minus 5. Yep, looks good to me. Okay, so let's see what do we get. 80 minus 110, that's minus 30. So minus 30t is equals to minus 105. Minus cancel. So 105 divided by 30 is in fact equal to 3.5. Okay, now the question called this 3.5. We will call this capital T, so we'll call this capital T also. There you go. Okay, why did we equate the displacements? Because the two particles coalesced. So then the question says, find the height above O at which the particles collide. So you know the time at which they collide. If you want to find out the height, simply plug in this time into any one of the equations. Okay, simply plug in the time into any one of the two equations. So I can plug it in A, you can plug it in B, it really doesn't matter. Because in both cases, the displacement is being measured from the horizontal ground for both objects. So 80 times 3.5 minus 5 times 3.5, the whole thing squared. So that means 80 into 3.5 minus 5 into 3.5, the whole thing squared. So that's equal to 218.75. So the displacement is equals to 218.75 meters. ठीक हो गया? Okay. Find the time from A being projected until C returns to O. ठीक है. Just seeing if there's another part. Find the time from A being projected until C returns to O. Now what's C? C is basically the combined particle. Okay. So what we need is basically the velocity right before collision. Okay. It will obviously not collide at the same velocity at which it was projected. It will probably slow down. So let's find out A's velocity before collision, which can be done by using the formula V is equals to U plus AT, since we have the time of collision, that's 3.5, and we have the initial velocity, and we have the acceleration due to gravity. So AT plus minus 10 into 3.5, so AT minus 35, that's equal to 45. Okay, now let's do the same for B. So B's initial velocity was 10 plus minus 10 into 3.5 minus 1. Okay, remember, the time that B travels for is always 1 second less. So this would be equal to 2.5, 100 minus 25, that's equal to 75 meters per second. Okay, so that means right before the collision, the velocity of A, and remember, they are basically both traveling in the same straight line. We drew them separately for our understanding, but they are basically both traveling in the same straight line. This is how they're going. Acha. So let's make a two-way table, before, after, one column for A, one column for B, one column for A, one column for B, mass times mass and velocity. So the mass of A, so notice that the question said that they both have the same mass. Okay, so that means if the mass is M, this is also M. The velocity of A before collision is 45. The velocity of B before collision is 75. When they collide, they coalesce. So that means now their combined mass will be taken. And what's the velocity? We don't know. So that means 45m plus 75m is equals to 2mv. So 45 plus 75, let's see what's that equal to. That's equal to 120. So 120m is equals to 2mv, m cancel, v is equals to 60 meters per second. And the fact that it's positive means that after collision, okay, after collision, these two particles combined make particle C, and it's traveling up. And remember, when did this collision happen? Or rather, where did this collision happen? This collision happened at a point. This collision happened at a point 270, yeah, whatever the distance is, I'll figure that out. Okay, so here's one particle, here's the other particle. These particles have combined and they make particle C. And this collision happened at a distance of 218.75 above the ground. Okay, now what do we want? We want the time until it returns to O, there, which is basically the ground. Achha, here's the thing. Now the negative displacement concept will come in. So since the particle is traveling up, okay, and we want it to come back to the ground, so that means from the starting point, if we measure its displacement, okay, from the starting point to where we want it to be, the displacement will actually be negative 218.75. Okay, the displacement will actually be negative 218.75. So minus 218.75 is equals to ut. Now what's the initial velocity? The initial velocity is 60 meters per second. Okay, it's traveling up, so that means upward motion is considered positive, but because we want it to be 218.75 meters below the starting point, therefore the displacement will be negative. Okay, this minus sign is basically because we want it to be below the starting point. Below the starting point. Okay, so ut, that means 60t plus 1 upon 2 into minus 10 into t square. So that means minus 218.75 is equals to 60t minus 5t square. Let's move all the terms to the left hand side. So 5t square minus 60t minus 218.75. Solve this and you will get your answer. Okay, I'm not going to solve this. It's a simple quadratic equation which you guys can solve. इसको solve कर लें, answer आ जाएगा. Simple as that. मज़ा आया? पानी भी ख़त्म हो गया. Why not SA plus SB? Why would you do SA plus SB? They're equal. SA plus SB हम जब करते हैं when two particles are traveling in the opposite direction. Okay, and SA plus SB is equal to the distance apart. That is when we do that. Sir, you just wanted to laugh, didn't you? No, I didn't want to laugh. Why displacement negative? Because this is where the particle is. We want it to come down from the point of projection. That's why we're going to take displacement as negative. Okay? So what if in the first part the particles are not projected from the same point? So in that case, their collision will happen when they've both traveled the same distance. And if it's projected from a certain distance above, so we will take that into account as well. Isn't gravity going down positive? देखो बेटा, gravity is basically taking what it is at the time of projection. At the time of projection, it's going up. Okay, at the time of projection, it's negative. Because it's going up, that means it's negative. Why didn't I make 60 negative? Why would I make 60 negative? When upwards is considered positive, then if the object is going down, only that part will be considered negative. ठीक है, इसमें अगर आप लोगों को प्रॉब्लम हो रही है ना, so here's my advice. देखो, अगर एक पार्टिकल ऊपर जा रहा है तो ग्रेविटी को तो नेगेटिव लेंगे ना. Okay, if a particle is going up, then obviously we'll take gravity as negative. We won't take gravity as positive. We don't decide whether gravity is negative or positive. It depends where the particle is going. So basically, we are looking at the story from the point of projection. From the point of projection, it's going up. That means acceleration will be negative. But we want it to be 218.75 meters below the point of projection. So if you want the particle to be below the point of projection, you will take the displacement as negative. Simple as that. Achha, why did I do 45? So right before collision, A was traveling at a velocity of 45, B was traveling at a velocity of 75. So moment, force times velocity plus force times velocity is equals to the combined mass times velocity. Okay? So why t minus 1? If the particle is projected 1 second later, we always do t minus 1. I think ज़्यादा पढ़ने से ना आप लोगों का दिमाग शायद उल्टा काम कर रहा है. So I think I should probably wrap things up. I will do one. एक काम करते हैं. Let me do one more question. Because अब आप लोगों का दिमाग उल्टा काम कर रहा है. And let's wrap things up. Achha, I think the February-March question that you guys are talking about, I think I've already solved that question in one of the streams that I've done. I'm just going to pick one nice question and wrap things up. कोई मुश्किल मैं ढूंढ रहा हूँ कोई मुश्किल वैसे मुश्किल सवाल कराता हूँ तो आप लोग जो हैं वो बिल्कुल बौखला जाते हैं आसान सवाल कराता हूँ तो आप कहते हैं ये तो बहुत आसान है चलें एक कार और ट्रेलर का सवाल मैं ढूंढ रहा हूँ विद एनर्जी मेथड ओके फाउंड इट हियर इट इज पुली वाले मैक्सिमम हाइट अगर आपने देखना है तो मेरी पुली वाली स्ट्रीम जाके देख लो ठीक है so the question that I found of work energy power is this one yeah okay let's do this question it's a fairly easy question I know ठीक है all right now so last one in the PDF is confusing which last question अच्छा now you guys pick ये वाला करना है या the previous one quickly pick this one or the last one just say this or that This for this question, that for the previous question. वैसे ये कर लेते हैं, इसमें हमारा पुली और वो दोनों कॉन्सेप्ट्स कवर हो जाएंगे. ठीक है. Yeah, let's do this. इससे हमारे दोनों कॉन्सेप्ट्स कवर हो जाएंगे. Alright, now. A particle P is released from rest with the two particles P and Q of masses 2.5 kg and 0.5 kg are respectively are connected by a light inextensible string. ठीक हो गया. Alright. Particle P is released from rest with the string taut and slides down the plane. The plane is rough with coefficient. ठीक है. Okay. So this is the last question, fellas. ठीक है. Because after this, you guys should sleep. Alright. Now, let's look at things from P's perspective. Okay, so P's weight component acting down the plane. Okay. And the component parallel to the plane right here. So this is 25. This will be 30 degrees. Okay, so that means this is 25 sine 30. This will be equal to 25 cos 30. 25 cos 30. Achha, is this rough or smooth? The plane is rough. Yeah, so that means I need to take the normal reaction force into consideration. Achha, also, this is the direction in which particle Q will move. This is the direction in which particle P will move. That means it's due to tension that it will move up the plane, which means the frictional force will be acting in this direction. Okay, so double arrow to show the direction in which the object is moving. Frictional force always opposite to that. So that means the force due to which P will move up is... No, wait a minute. Let's read the question. Particle P... Oh, wait, it slides down the plane. Oh, wait a minute, it slides down the plane. Okay. I know chat mein sab cheekhna shuru ho gaye honge. Khair, anyway, I figured it out. It's moving down the plane, so nothing to worry about. That means its tension to chalo ek hi direction mein act karegi, but since it's moving down the plane, that means the frictional force will be acting up the plane. Okay. Particle P is released from rest with the string taut. The plane is rough with and slides down the plane. Okay. Yeah, so obviously it's the heavier particle, it will slide down, of course. Okay. So the force due to which it slides down is 25 sine 30. The force preventing it from sliding down is the tension and the frictional force. Okay, and this is equal to 2.5a. Now, while we're at it, let's deal with frictional force. Frictional force is equals to mu times r. So frictional force is equals to 0.2 multiplied by 25 cos 30. So that means the frictional force is equal to 0.2 times 25 cos 30, which is equal to 5 under root 3 upon 2. ठीक हो गया? Okay. Now 25 sine 30 will be 12.5 minus t minus 5 under root 3 upon 2 is equal to 2.5a. Now let's look at things from Q's perspective. So from Q's perspective, Q will move up, obviously, double arrows. Okay, there is no friction here. So the reason why it moves up is because of tension. Weight acts downwards. That's 5 newtons. So Q ki kahani seedhi si hai. That's t minus 5 is equals to 0.5a. Now, as I add the two, okay, we will get acceleration and we will get tension also. So t gets eliminated. Okay, so I'll just do this part directly in the calculator. 12 minus 5 under root 3 upon 2 minus 5 divided by 2.5 plus 0.5. So that's 3. So we get A, which is equal to... Achha, wait a minute. Kuch galti kar di. 12.5 minus 5 under root 3. Sorry, maine under root 2 le liya. Minus 5 divided by 3. So we get 1.0566. So A is equals to 1.0566. Directly stick around to save some time, which means correct to 3 significant figures, it's going to be 1.06 meter per second square. Okay, this is the easy part. Now things go uphill. Okay, now it literally goes up the plane. Let's see what happens. Use an energy method to find the speed of the particles at the instant when they are at the same vertical height. Okay, at the instant when they are at the same vertical height. Achha ji. Now let's delete this for a minute. Let's take a screenshot. Let's bring this mess back. Now, pay close attention. First of all, same vertical height. ठीक है, सबसे पहले तो ये issue resolve कर लेते हैं. So P is sliding down the plane, keep that in mind. If P is sliding down the plane, that means, let's suppose that it slides down x meters. Okay, let's suppose that it slides down x meters. Now, if this slides down x meters, that means that this will move up x meters. Okay, and they will both be at the same height. They will both be at the same height. Okay. Acha. Up the question is that as far as Q is concerned, we can see that the change in height is x. But as far as P is concerned, what exactly is the change in height? Because x is not the height for P, x is basically the hypotenuse. Okay, so that means we will have to consider this triangle separately. Okay, where this is 30 degrees and this would be equal to x sine 30. Okay, this would be equal to x sine 30. And here's the thing. Because they were initially 2 meters apart, that means the distance that P moves down, which is equal to x sine 30, and the distance that Q moves up, which is equal to x, must be equal to 2. Okay, so initially they're 2 meters apart. P moves down, Q moves up. That means the distance that P moves down and the distance that Q moves up, which brings them at the same height, is equal to how far apart they were initially. Okay, so that means x sine 30, the distance that P moves down, plus x, which is the distance that Q moves up, and this brings them to the same height, which means they are now both, this combined distance is equals to 2. Okay, let's take x common. So that would be sine 30 plus 1. Okay, so pay close attention to this part. This is probably the most confusing part of this question because from this point onwards, it's literally all downhill. So x is equals to sine 30 is half, half plus 1 is 1.5. So 2 over 1.5, that's equal to 2 divided by 3, 4.3. Yeah. Okay, so I'll explain this again. P moves down, Q moves up, and now they're at the same height. Initially, they were 2 meters apart. So the distance that P moves down plus the distance that Q moves up is equal to how far apart they were initially. Okay, P moved x sine 30. Now, in case you're wondering how I got x sine 30, the hypotenuse is x, this angle is x, so that means the opposite will be x sine 30, and this is equal to x because this is moving vertically anyway. All right, now. अच्छा सवाल क्या था मैं तो ये भूल गया. Use an energy method to find the speed of the particles at the instant. Now, we have to use an energy method. Okay, we have to use an energy method. There's no two ways about it. So how do we use an energy method? Let's have a look. So because they're connected, that means we can combine them. We can take the combined mass. Okay, and as far as tension is concerned, work done by tension will cancel. Okay, but there is work done by frictional force. There is change in potential energy. Okay, so let's write down the energy method, which is total work done is equals to change in potential energy plus the change in kinetic energy. Okay, now total work done basically means by minus against. Now there is no external driving force. Okay, weight is not a form of driving force. External driving force means a pulling force or a pushing force or maybe an engine or something, but there is no such thing. So by is 0. However, there is work done against. Okay, how is there work done against? Because there was a frictional force, correct, which is 5 under root 3 upon 2. And this frictional force has basically acted on x, okay, because P has moved down, frictional force acting in this direction. So that means work done against friction. Let's make this arrow for frictional force. Work done against friction is basically 5 under root 3 upon 2 multiplied by the distance. And what's that distance? That's equal to 4.3, okay? Is equal to the change in potential energy. So as far as Q is concerned, Q gains potential energy. So that would be 0.5 times 10 times the height, which is equal to 4 upon 3. Okay, so Q gains potential energy. P, on the other hand, loses potential energy. So we'll subtract that. Minus 2.5 into 10 into, what's the height? Acha, what's the height? Be careful. Oh crap, battery dead ho gayi. Let me connect the other iPad, just a minute. चलो मैं इतने चैट एनेबल कर देता हूँ. And I appreciate that. एक मिनट दीजिएगा बस. No, you won't consider. Okay, t को हम इसलिए नहीं कंसिडर कर रहे. t को हम इसलिए नहीं कंसिडर कर रहे because t कैंसिल आउट हो जाएगा. Okay. t को हम इसलिए नहीं कंसिडर कर रहे because t ने इवेंचुअली क्या होना है. t ने इवेंचुअली कैंसिल आउट हो जाना है. ठीक है. अच्छा, just a second. I just hope the work is saved. Okay, great. Just a second, I'm trying to connect my other iPad. Here. So what does it look like? Okay, now. So, where were we? Wait, what happened? Okay, sorry guys. मैंने वो सारी annotations तो की नहीं import. This is the last question, okay? So you can explain the X method again? Okay, I'll explain the X method again. Can equate energy method individually on both particles. What do you mean equate? Equate करने का क्या मतलब है? चल हाइड उर्दू में दोबारा समझा दें. चलें बिल्कुल समझा देते हैं उर्दू में. बेटा जब एग्ज़ाम इंग्लिश में होगा तो मेरे उर्दू में समझाने से क्या फ़र्क पड़ेगा? चलो I'll just import it here. Okay, so first of all, let me explain X again. So this particle comes down X meters, okay, and this rises X meters. Now, we need to find out the change in height. The change in height can be calculated by making a 90-degree triangle. Okay, angle is 30. We need to find out the opposite side, which will be equal to x sine 30. ठीक है, अब x sine 30 is the distance, is the decrease in height of P, x is the increase in height of Q, and this combined will be equal to 2 meters because that's how far apart they were. Okay, so we were talking about P. So P loses kinetic potential energy because its height changes. And what is the change in height? The change in height of P is basically equal to x sine 30. Now we already have the value of x, which is equal to 4 upon 3. So 4 upon 3 sine 30, and what's that equal to? Let's work it out. 4 upon 3 into sine 30, that's equal to 2 upon 3. Okay, so that means the change in height for P is basically equal to 2 upon 3. Okay, so 2.5 into 10 into 2 upon 3. Now plus, what are we supposed to find out? We're supposed to find out the speed. So that means now, as far as kinetic energy is concerned, we will consider their combined mass, because they both will be traveling at the same speed. So their combined mass will be 3 multiplied by v square. Okay? Now let's work this out. Won't the height in GPE be the height from horizontal ground? No beta, it won't be from horizontal ground. It will be क्या हो? लग रहा है ज़्यादा पढ़ लिया आप लोगों ने. ठीक है, जिसको लग रहा है ना उसने ज़्यादा पढ़ लिया है और उसके दिमाग अब उल्टा चल रहा है, वो प्लीज़ स्ट्रीम देखना छोड़ दे. ठीक है, it's always the change in height that we consider. So this turns out to be minus 10 under root 3 upon 3, okay, is equals to, now I know why Sir Zen doesn't keep a stream. Lengthy stream on a day before the exam. I think I'm going to do the same from next time onwards. 20 upon 3 minus 2.5 into 10 into 2 divided by 3. So that's 50 upon 3. Okay. Is plus 3 upon 2 is 0.5. So 0.5 v squared. Okay. Now you can't do change in P is equals to change in Ki. Why? Because there are external forces to consider also. Okay, so let's work this out. Minus, let's make a fraction, 10 under root 3 upon 3 plus 20 upon 3 minus 50 upon 3. So we're looking at a certain value. Okay. Yeah, let's just make sure that everything's correct. 0.5 and 10, 10 into... Sorry, this will be 5 into 4, 40 upon 3. Sorry, not 20 upon 3, 40 upon 3. 1.5, what 1.5? Achha, 3 upon 2 is 1.5. Yeah, this is 1.5. ठीक है. एक और गलती है, ये 40 upon 3 है. Okay, now. So once again, minus 10 under root 3 upon 3 minus 40 upon 3 plus 50 upon 3. So this is equal to, एक second, there is still some 20 upon 3. It's 20 upon 3, are you sure about that? 0.5, oh yeah, it's 20 upon 3. क्या हो गया यार, sorry. Say. So I'm looking at a certain value which is 4.22649. I'm not rounding off because it's not the final answer. Is equals to 1.5 v squared. So we divide this by 1.5. So I'm looking at v squared to be equal to a certain value. Okay. Then let's take the square root of it. So v squared is equal to 2.8176, which means v is equals to 1.6785, which means correct to 3 significant figures, and that's how you're supposed to give your answer, is 1.68 meter per second. There you go. ठीक है, अब यही आंसर है. हाँ, मैंने भी ज़्यादा पढ़ लिया. ठीक है, एक्चुअली मैं एक तो ना छोटा सा iPad यूज़ कर रहा हूँ, इसको देखने में इसमें प्रॉब्लम हो रही है. ठीक है, आई थिंक मेरी भी आंखें कमज़ोर हो गई हैं. एनीवे, सो आज के लिए इतना काफ़ी है. ठीक है, दिस इज़ फ्रॉम मई जून 2024 पेपर 4 वेरिएंट 2. बाकी हम करेंगे कल की स्ट्रीम में. सेड वी हैव टू शो, यस यू डू हैव टू शो एवरी कैलकुलेशन. ठीक है बेटा, टेंशन हमने इसीलिए इग्नोर कर दी. पहली बात ये कि आप लोग इतना कैप्स लॉक में क्यों लिखते हैं? लिटरली फील्स एज इफ यू गाइस आर शाउटिंग. सो रीज़न व्हाई आई इग्नोर्ड टेंशन इज़ बिकॉज टेंशन इज़ कॉमन फॉर बोथ द पार्टिकल्स. ठीक है, for one particle it is a driving force, for one particle it's a resistive force. Okay, so ultimately it will cancel each other out. Simple as that. Okay, so how is iPad at 9:41? Actually, that's a story for a separate stream. Okay, but anyway, I'm going to stop here. If there are any S1 students, P3 students, so we'll have S1 and P3 streams. M1 students, I will post a good luck message for you guys very soon. Okay, make sure to watch it. And yeah, that's about it. Just remember, start with the easy questions. Okay, and mark all the easy questions first. Please make a rough sketch, whether you're dealing with a kinematics question, whether you're dealing with a momentum question, whether you're dealing with a forces question, make a rough sketch. That's very important. It will give you a perspective. ठीक है? अगर कुछ ना समझ आए, so just try and break the question down into multiple steps. This usually happens in M1, or this usually happens in momentum, usually happens in kinematics. Okay, so break the question down into multiple steps. You will definitely be able to understand it better, inshallah. ठीक है? Acha. Also, final answer correct to 3 significant figures, but in between, keep your answer correct to 5 significant figures at least. Okay, and if you have, let's say, sine alpha is equals to 0.05, please don't find out the angle, just use sine alpha as 0.05. Okay, and find out cos alpha also in exact form and use it as it is. Okay, don't go through the pain of finding out the angle and then using that angle when you're breaking down forces. Okay. So yeah, that's about it. Remember to first see where the object is moving, and then upon that decide where friction is going to act. Keep all that, throughout, just keep using your common sense. Okay, throughout the paper, just keep using your common sense. Make sense of your answer. Okay, make sense of your answer so that you can see whether it's right or wrong. ठीक है? अगर let's say जैसे अभी हमने kinematics का question किया था, so we were supposed to find out a value of t which was in between two values, so make sure that your answer is actually in between two values. ठीक है? Anyway, so I'm going to stop here. I'll see you guys, inshallah. Those of you who are giving S1 in the next stream, those of you who are giving P1 also, or P3 also in the next stream. No, I will not private this video. This video will stay. And jate, if you haven't liked the stream, I would really appreciate to do that. And also subscribe to the channel if you haven't done that yet. So that's it, fellas. Take care. Allah Hafiz.